Okay, thank you for being patient. So in the last class, what we did, also one more thing, guys, you can use the chat if you want. If you have any doubts during the session, please use the chat to ask the doubts. Okay, please let me know if there are any doubts. Anyway, let's continue. So in the last session, we had started our discussion on scalars and vector quantities. Okay, scalars and vector quantities. And this is what we are going to continue in today's class. Today's class is going to be all about scalars and vector quantities. It's all going to be about scalar and vector quantities. Now, we started out with the most basic definitions of scalars and vectors. Okay, scalars and vector quantities. Okay, so one thing, basic thing that we know about scalar quantity is that it has magnitude. Vectors, on the other hand, has magnitude as well as direction. Okay, but understand this is not the final definition of scalars and vectors. I told you there are exceptions to it. Like for example, current. Current is a quantity that is essentially has the magnitude and direction, but it is categorized under scalar quantity. So we wrote a bunch of examples like current, speed. Okay, now current is one of those exceptions. And then what else? Distance and everything. We wrote an entire list. Okay, you can find out other quantities. Okay, uh, from your textbook. Over the period of time, we'll be discussing more and more quantities in physics, and those quantities we'll always know whether it has a direction associated with it or not. Vector quantities, on the other hand, are something like velocity, displacement. Okay, velocity, displacement, uh, force, torque. Okay, and so on. So these kind of quantities are vector quantities. These quantities have a magnitude as well as an associated direction to this. Okay. Now, talking about that exception, what is it that makes a vector vector? It having a magnitude as well as a direction is not enough to make it a vector. So what is it that makes vectors like the final condition? It's known as the law of vector addition. Okay, so a vector has to follow these three conditions. It should have magnitude, it should have direction, and it should follow the vector law of addition. Okay, vector law of addition. So
Excuse me,
what
sir.
exactly is the vector law of addition though? Okay, so to essentially know that, we need to first understand how do you represent vectors. Okay, how do you represent vectors? So this is the next topic that we are doing, representation of vector.
Sir, I have a doubt, sir. Uh,
Okay, go ahead.
what is magnitude?
What is magnitude? Okay, is this your first class?
No, sir, second class. But I didn't understand the meaning of magnitude in my ninth and tenth also. I never asked this doubt.
Okay, so for example, magnitude essentially means what is the value. Like for example, there are multiple parts to a particular measurement. Like give me a physical quantity, like for example velocity. Okay, now velocity has three components to this. When you like for example, if you ask someone what is the velocity of car, they'll probably say 50 meters per second in the north direction, let's say in the north direction. Okay, so there are three components. These are names: magnitudes, units, and direction. So here, this is the first component. The number 50, the number 50 here represents the magnitude. So we call this numerical part of this physical quantity that it is representing the magnitude of this particular quantity. Okay, this is the magnitude of the particular quantity. Meter per second, this symbol particularly, this signifies the unit of this particular physical quantity, and n cap, and this being the north, is the direction you're representing using a direction. Okay, so does that make it clear? The numerical value, now this numerical value will can keep on changing, the direction keep on changing, unit does not change.
Okay, sir.
Does that give you a little bit of clarity?
Yes, sir.
Okay, so magnitude is essentially the numerical value inside that. Okay, now the next part of discussion is how do you represent a vector quantity? Well, a vector quantity can be represented using this. Okay, a vector is slash, the modulus symbol of a, and a cap. Again, this is something that we discussed last class, a little bit of revision. This is essentially how you represent a vector quantity. Like if this is force, then you would represent it like this. Okay, force vector. This is essentially the number associated with it. We call this the magnitude. And this is the direction associated with this. Direction associated with this. Now, direction can be given in many different ways, but the standard way of using this is this. You use a coordinate system, x, y, and someone tell me where is z. So I see some people imagining z in this direction. Okay, is this z?
Sir, no, Z
So it
is
would be a third
not.
dimension then.
Ha. So essentially, when I draw this, I mean ki I have an arrow which is coming out of the screen. Guys, imagine a arrow which is coming out of the screen. Okay. So some people believe ki Z is that the angle between x-axis and z-axis. If I ask, some of you will tell me, sir, it is 120 degrees. Is it 120 degrees?
No, sir, 90.
Sir, it's 90
It is
degrees.
it is actually just 90 degrees. This z-axis is coming out. Okay. So how do you represent directions using this standard coordinate system? Well, you use these x cap, y cap, and z cap. Okay. And the cap on top, I think last class someone asked, this is called cap only. The cap on top is known as cap. Okay. So x cap, y cap, z cap. Now, for example, if I say 1 x cap plus 2 y cap minus 3 z cap, z cap, what does this imply? Now, if I say this is the displacement vector, what does this signify? It means I am traveling 1 meters along the x-axis, 2 meters along the y-axis, and 3 meters opposite to the direction of z-axis, opposite to the direction of positive z-axis. Okay, so that this is what it means. If you have any doubt regarding this representation, please feel free to ask. Now notice here this 1 is the magnitude, x cap is the direction, 2 is the magnitude, y cap is the direction, 3 is the magnitude, z cap is the direction. Okay,
Sir, can we add these, like, though they're in different directions?
no, we cannot. Like for example, if you went 3 meters to the right and 4 meters in the forward direction, what will be the displacement? Will
5
it be
meters.
5.
will it be 7?
No, 7 would be the distance.
No, sir.
Yes. So if you have if these were scalar quantities, you could have directly added them. 1 plus 2, 3, 3 minus 3 is 0. But that is not the case. Okay. So these are vector quantities. You cannot add the numerical values if they are in different directions. Okay. You can only directly add them if they are in same direction. For example, if I say key, like for example, I have 1 x cap plus 3 x cap. This you can write as 4 x cap because these vectors are in the same direction. Okay. But if you have 1 x cap, like for example, if you have 3 x cap plus 4 y cap, you cannot write this as 7. Okay. I hope that makes sense. Let's move forward. Okay, if you understood this. The next type of representation, well, this is one part of representation. Okay. The second type of representation is known as the graphical representation. The graphical representation. The graphical representation. Okay. Now, what is graphical representation? Well, in graphical representation, you have to, again, to show a particular vector quantity, you need to assign two things. Well, the magnitude and the direction, right? So in graphical representation, we just go like this. Okay, we say okay, I think I accidentally click something else. Automatic shoot. So when you make an arrow like that, this essentially means we have a vector quantity in this particular direction, and here the length, okay, the length of this particular arrow represents the magnitude. Okay, so if I make another vector near it, which is, let's say, half the length, can you tell me this, what will be this? This will be essentially a by 2. I hope that makes sense. the magnitude will become half. The length of the arrow represents the magnitude. So if you make half an arrow, the magnitude becomes half. If you make double the size of the arrow, it becomes twice. Okay, this. And how do you give the direction? How do you represent the direction? Usually with an angle. Okay, so how do you represent, how would you represent this particular vector? You will say, okay, so I have a vector quantity. A vector is making, okay, theta with the horizontal, with the, I would rather say, positive x-axis. Okay, so this is how you represent a vector graphically, and you will understand more when I actually do it and solve problems on it. Okay, then you'll be able to understand the significance of this representation. But here, the only few things you have to remember is that in graphical representation, you give the magnitude of the vector using the length. Okay, and you give the direction of the vector quantity by giving a angle with the positive x direction. Okay, so here you can see this is essentially the positive x direction, and the angle a vector is making with the positive x-axis is given by theta. I hope this makes sense. Okay, this is the graphical representation of vector quantities. If you have any doubt, feel free to ask. Okay, write down resolution of vectors, the next topic. Resolution of vectors. Okay, now what is resolution of vectors? Well, we understood there are two types of representation of vectors. One is the graphical representation, which is pretty much easy. It gives you an arrow and a theta. And the other one is essentially, you know, a algebraic form. Okay, or this is also, please write down the heading if you haven't written. Okay, this is the algebraic form of representing a vector. Okay, this is also known as the component form sometimes, and I will tell you why it is known as the component form. Okay, this is the algebraic form of representing a vector. The second one is the graphical representation. Let's move forward. Okay, resolution of vectors. Now, by now you have understood that there are two types of representing a vector. One is the graphical method, and the other one is essentially representing the vector in terms of some magnitude and some direction. Okay, now we need to know how to convert from here to here. Like if it was given in a graphical format, will you be able to break it into the algebraic format? And if it is given in the algebraic format, are you able to convert it into graphical format? That's the next question, and hence the topic resolution of vectors. Okay, now for example, you have the xy axis, which is given like this.
Sir, can you go up one, sir?
To the previous page?
Yes, sir.
Okay, I can, but please remember that I'm going to share all my notes after the class, so if you miss something, no need to worry.
Only one sentence, sir. Done, sir.
Just take running notes to essentially register whatever I'm teaching in class. If you miss something, just keep little bit of space. I'm going to share my notes after class. Okay, but focus more on understanding what is going on in class. Okay, if you need time to write, just let me know. So let's say I have the standard coordinate system. This is x, this is y, and I give you a vector like this. Okay, I give you a vector quantity like this. This is some vector quantity, maybe force, maybe velocity, maybe any kind of thing. It's a vector quantity. Okay, and let's say it makes theta with the positive x-axis direction. Okay, so I'm making a horizontal line like this. Okay, and let's call this angle theta. Let's call this angle theta. Okay, and we know the length of this particular vector is its magnitude. So I am representing the magnitude here. Okay, the length of the vector is representing its magnitude. Okay, now my idea here is to find out this particular length and this particular length. Can you help me with this? I want to find these lengths. This, by the way, is 90 degrees. I dropped a perpendicular. Okay, So can you guys help me find out these lengths? This is the perpendicular length. Can you tell me what is the perpendicular length?
So can we find it out using trigonometry? Like if we know the angle's length, then we can find it out like by.
Yes. So we are going to use trigonometry to find out this length. Yes. So how much is the length?
So for that, we should know the value of the magnitude and theta.
We know this magnitude is A. Okay, let's say this is A vector and this magnitude here is A. This angle right here is theta. So define cos theta. What is cos theta exactly? Cos theta is base upon hypotenuse, right? Do you agree with me? It's
Yes,
base
sir.
upon hypotenuse. So this base length right here, this base length right here would be how much?
Cos theta into A.
A cos theta. A cos theta. Nice. So this length is how much? A cos theta. Cool. What about sine theta? How do you define sine theta? This is defined as perpendicular
By hypotenuse.
by hypotenuse, and hypotenuse for us is A.
A.
So the perpendicular length is actually how much? This is
A
equal to
sine theta.
A sine theta. Okay. So what did I just do? I broke the vector that was given to us into two parts. Okay, I broke it into two parts. One in the x direction. Okay, so let me show it with a different color, like this. Okay, this is A cos theta, I believe. Okay, this is a vector quantity which is going in the x direction. Okay, and there is this other quantity which is going upwards, A sine theta. A sine theta. Okay, so the A vector that I initially had can be written as A cos theta, x cap plus A sine theta, y cap. Tell me if this whatever I wrote here makes sense to you. If it does not, please ask.
Sir, I
Can
have
you
one
repeat the
doubt.
last step?
Yes, one by one, please.
Sir, when the base is A cos A, sir, then it will be A cos A by A, no, sir. That means A will cancel, no, sir. Does that mean cos theta equals cos theta?
Okay, I'm unable to understand your doubt. Can you repeat one more time?
Cos theta equals to base by A.
Yes.
Now base is equal to A cos theta.
Okay. So wait. Let me just copy this. So you're saying ki base is equals to A cos theta,
Yeah.
then
And cancel, no, sir.
and cos theta cancels, right?
A
A,
will cancel.
A cancel. 1 is equal to 1.
So the answer is 1.
No. The answer is not 1. You just proved ki 1 is 1. See, like for example, let me give you an equation, okay, and help me solve this. X square is equals to 4. Help me solve this, Aditya.
X is equal to 2.
X equals to 2. Okay. Now put this 2 back in this original equation. 2 square equals to 4. 4 equal to 4. Cancel out. 1 equal to 1. Is the answer 1?
No, sir.
Did you understand your mistake?
Yes, sir.
Okay, you solved an equation here. You did not know the value of base in the beginning. Okay, you didn't know the value of the base in the beginning. You found out it is A cos theta, and you back substituted to the same question again, and you're saying Q1 is equal to 1. So that was the mistake. Okay, other doubt?
Yes, sir.
So I didn't understand the last step. The last.
The last step. Okay.
Yeah.
So see, I had a vector in some random direction that was A. Using trigonometry, I broke it into two perpendicular direction, one along the x-axis, and its length was A cos theta. And I broke it in one into the y direction, and the length was A sine theta, right? Up to here, you understood?
Yes, sir.
Okay. Now A cos theta was in the x direction. So if I want to write this in the, now what was the goal? Resolution. When I started with resolution of vectors, my idea was if I'm given the graphical format like this, A vector with an angle theta is given to me, can I represent this vector in terms of the algebraic format where there is x cap and y cap? Can I break it into something like, okay, like for example, I'll give you an example like this. Let's say the displacement is 5 meters in this direction. If I break it, can I make it 3 meters in this direction and perpendicularly 4 meters in this direction? Do you understand? Okay, so 5 meters, that random vector can be represented as 3 meter in the x direction plus 4 meter in the y direction. Does this make sense?
Yes, sir.
Okay, so in the last step, what I did is I took a vector quantity. I found out key that vector quantity can actually be broken down into components. Components, these are also known as components. Okay, this is also known as components. So can I take a vector and break it into components such that I can express this in a standard form or a component form or an algebraic form? Okay, so yes, we can. All you have to remember is this particular statement. Okay, and I in the offline class I made everyone repeat after myself. So without turning on your mic, please repeat after me. This particular one statement you have to remember, because you have to do it every single time. You cannot solve the triangle at that moment. I hope you understand what I'm saying. Okay, you have to take components for every vector quantity you meet in physics, and there's a lot of vector quantities in physics. Okay, so I don't want you to have essentially a lag in doing those problems. If you solve the triangle every time, it's like you're doing 8 times 5 manually every time. You're supposed to remember 8 times 5. Okay, now, what you have to remember is if you have a vector quantity like this, okay, let's say I give you there is 10 Newton force acting on a certain block, which is making an angle of 60 degrees with the horizontal. How do you take this particular situation and break it into components? Let's consider this is the x direction, the standard x direction. This is the standard y direction. How do you break this particular force into its components? Well, it's very, very easy. Repeat after me. Towards theta, towards theta, cos theta. This is what you have to remember. Towards theta, cos theta. Away from theta, sine theta. Okay, these are the two statements. Please repeat after me. Towards theta, cos theta. Away from theta, sine theta. Okay, so these are the two statements. The only thing you have to remember. Okay, now using this particular statement, I'm going to erase this. Should I erase this? No, I'm going to keep it for anyone who misses out. I'm going to put it at the bottom of the page. Okay, so you won't find this in any standard text. This is something I came up with. So don't be like, sir, ye to kitab mein nahi hai. Okay, it's just something that I used to remember. Okay, now I know ki by judging by the location of the force, I know I can break it into two components, and one component will be like this. Okay, and one component will be in the vertical direction. Okay, I can draw it on the left side also. It doesn't really matter. Okay, it doesn't really matter. I can, but one thing is, one particular component will be pointing towards the x direction, and the other one will be pointing towards the y direction. Now, out of these two components, one component is actually towards theta. So towards theta means in the direction of 60. So this is going to be a cos 60. So that is 10 cos 60. Okay. Now the other component is away from theta. It's not close to 60. It's away from 60. So that means this is going to be 10 sine 60. 10 sine 60. Okay. So give me the values. Cos 60 is half. So this is going to be 5
5.
in the 5 in the x direction. And I believe this one will be 5 root 3 in the y direction. So how do you represent the force in the algebraic format? Well, you say it is 5x cap and essentially plus 5 root 3 y cap. Okay, separate quantities. This is how you represent the vector that is given in the graphical format into the coordinate format or the algebraic format. Okay.
So x cap and y cap are just like the directions.
Yes, x cap essentially means go in the x direction. Y cap means go in the y direction. Okay. So
Now,
like
if in the like if it's towards the negative x-axis, will become minus 5x cap.
yes, it does.
Okay.
Okay, that is what I was gonna talk about in the next one. Okay, next example. I hope everybody has written this. A physical significance of what x cap and y cap. These are also the name of these are unit vectors. These are unit vectors. What is unit vector? Unit vector is essentially a vector that is used to show direction only. It has its magnitude will be one. Okay, uh, because when you multiply one with anything, like for example 5 meters multiplied by 1 is still 5 meters. Okay, so hence unit vectors will have magnitude of 1. It does not affect the original magnitude. Okay, now what is the physical significance of unit vector? Like for example, someone asks you where essentially is the nearest restaurant. Okay, where is the nearest restaurant from your location? So one way is that you walk with the person and take him to the restaurant. Okay, now that is the entire vector. But there is also a scenario where you will just say ki ha, this is where the restaurant is. You're pointing towards that restaurant and you're saying ki, okay, this is where the restaurant is. That is the physical significance of unit vector. You are not giving the magnitude, you are not actually going to the restaurant, but using a particular direction of 1 meter, showing ki ha, this is when you need to travel to get to the restaurant. Okay, so that is the physical significance of a unit vector. I hope that makes sense. Okay, let's move on. Let's do one more question, and the third question you will do on your own. So this is the second question I'm going to help you with. Okay, so let's say there is a ball on the table. Okay, there's a ball on the table, and this is the top view. I'm looking from top. Okay, I'm looking from top, and let's say the ball is traveling in this direction with 10 meter per second. Okay, this angle being 60 degrees, this angle here is 60 degrees. Okay, this is the second question I'm doing. Okay, so you need to resolve this into the algebraic format. Okay, take standard directions as x and y. Well, again, I'm going to do the same particular statement I'm going to use. This is the vector quantity. I hope everybody understood the question. There is a ball. I'm looking from top. Okay, it's on a horizontal table, and it's going essentially in a tilted manner such that it's making 60-degree with the forward direction. Okay, it's making 60-degree with the forward direction. Okay, I'm gonna make the diagram slightly better. Okay, now, how do you find out the component form? Well, uh, first from judgment, I know this particular vector will have two components. One will be in this direction, okay, and one will be in the vertical direction. I hope that makes sense. If it doesn't, please let me know.
So
Okay.
can't we twist the diagram or like turn the diagram in such a way that we'll get x positive and y positive as well?
No, but that would defeat the purpose of the question, giving us a standard direction of x and y. Okay, so usually what happens is, like for example, you want to, in physics or in engineering, you want to build something. Okay, so there will be different softwares. I think some of you might have come across softwares like AutoCAD. Okay, AutoCAD and 3ds, I think. So these are the engineering softwares. Now I know for civil engineering and architecture I have a little bit of knowledge about mechanical engineering softwares. But other softwares, electrical and all, I don't know. But most of the engineering, if you're into core engineering and you're building something, the first thing that you need to decide is the origin. Okay, because you have to understand, a computer does not understand a particular 3D space like it will not recognize. Okay, it's not like it has thinking ability. It's all based on math. So the first thing you need to define in a room for a computer is the origin. Let's say where you are sitting, you are considering 0 comma 0 comma 0. That's the location of your body. Okay, now let's say you want to tell a computer key where exactly is uh, the phone located from you. So you'll say okay, 1 meter in the forward direction, 2 meters in the right direction, and probably and you go a little bit vertically up 15 centimeter, and that is where your phone is located. Okay, so that right there is the three dimensions that I'm talking about. Okay, x, y, and z. The first thing that we need to do is define x, y, z. Now based on that, your body could be traveling, I don't know, in the left, in the right, in the up, down, or any intermediate direction. Okay, and you can always break it down into the standard xyz directions. Okay, So to answer your original question, can I rotate the body? Okay, can I rotate the body and just bring it to the first quadrant? I think that was the question. She wanted to bring it to the first quadrant. The answer is no, because this the wait 1 second. Yeah, the coordinate axis came first and a ball came second. You have to understand the chronology here. Okay, so the ball cannot be rotated, because if you rotate, that means it's not representing the actual motion of the body. Okay, so this is given in the question 60 degrees. Okay, so now let's take components. Towards the theta is going to be cos theta, so that means this is going to be 10 cos 60. This is going to be 10 cos 60, and away from the theta is going to be 10 sine 60. Okay, so again this is going to be 5, and this is going to be 5 root 3. Okay, now I'm going to write this in the component form. So I'm going to write the velocity of the ball is actually minus 5 root 3 x cap and 5y cap. Now why did I use minus? Minus to represents ki to compared to the standard direction that was supposed to be x, the actual velocity of the ball is actually is in the reverse direction of x axis. It's not in the same direction as x, it's in the opposite direction of x. Okay, so that's why the minus sign, minus 5 root 3 x cap. You can also write this as 5 root 3 minus x, means the exact same thing. It doesn't make any difference. You can write like this also. Okay,
So,
yeah, yes.
is it necessary to write y x cap first and y cap second?
Well, the practice is to write y cap first x then y, just to increase the readability of things. But if you write 5 y cap plus 5 root 3 minus x cap, you'll give the same answer. Okay, okay, so it doesn't really matter, but yeah, try to go for x y z. Okay,
Okay.
So for these kind of questions, how do we know like which triangle to take? Now, what I did first was I found out that the other angle was 30 and I took the smaller triangle.
again, not the triangles, but yes, you can also do the same problem using 30 degrees also. Okay, do not solve for triangles, you just remember the statement. Okay, so let's say if you go for this as 30 degrees. Okay, so you know that this component is again going to be in these directions only. This would be 10 sine 30, and this will be 10 cos 30. Okay, now if you solve this, you will understand, you'll get the exact same answer. 10 cos 30 is 5 root 3, 10 sine 30 is 5. So it doesn't really matter which angle you are taking, but I took the angle that was given to me because why to think additional step of finding out this angle. Okay.
Okay, sir.
But yeah, if this can also be done using 30 degrees, it's gonna yield the same exact same answer. Okay, okay, now let's talk about let's give you a question from my side. Okay, so give me a vector quantity. We have discussed what displacement, force, uh, velocity. What else? Do you remember the vector list I gave in previous class?
Yes.
Momentum.
Momentum. Okay, so there is a car. Okay, oops, and you know, it's actually coming downhill. Rotate 45 degrees. Oops, okay, it's cool. Okay. It's going in this direction, let's say. It's going in this direction with an acceleration of oh, it's a momentum of, let's make it like this. Okay, should I make it easy or complicated? Let's make it easy only. I hope you understand the unit here. Kg meter per second means momentum. Okay, and let's say this angle right here, like the oh, like the angle that the road makes with the horizontal is, let's say, 60 degrees. Okay, express the and the momentum is parallel to the road, of course. Okay. Your job is to find out in component form, taking the standard directions of x and y. Okay. Imagine standard directions of x and y and find out the components of this momentum. P vector you have to find in component form.
So if we know the answer, can we write it in chat?
Yeah, please write your answers in the chat. 47 people are attending today's class. You're most welcome, but please feel free to participate. The more you participate, the livelier it gets. I get more energy. Okay. It's not a one-way interaction, it is a two-way interaction. Put more questions, more suggestions on the chat, and the class will become more fun. Participation is the currency of today's class. Yes, I got one answer. More answers, please. The assignment that I gave last class, some of you emailed me your answers. So rest of you, please, as well. I don't know if you're traveling, but if you are, then it's okay.
So is it possible to send your email once again in the chat after class?
What? I didn't understand your doubt.
Is it possible to send your email once again in the chat after class?
Now only I will send.
Okay, sir.
Yes, very nice. People are participating. I put my email on the chat, so just scroll to the chat. You'll find my email. Okay. So yeah, this is the same email I'm using to conduct today's class as well. Very nice. Let me keep this copied. After everyone has answered, I'll put my email one more time at the end of the chat. Yes, I feel really happy. A lot of you are giving me correct answers. Okay, okay. I feel like everybody is is everyone answer similar, or like did you just copy paste? I don't know. Yeah, I feel like people just copy pasted. OMG, you guys are so nice people. Just copying stuff. Dang. Okay, let's see. Okay, if I consider this to be like the standard, this is the standard x-axis. Okay, and this is the y-axis. If I break this into components, this is how it will look. One vector will be pointing like this. Okay, I don't know why I'm not able to make straight lines no more. Okay, okay, and the other one will point downwards. Okay, now how am I doing this? It just something common sense. Okay, if you have a triangle that is going like this, one vector has to go in this direction and the other vector has to come down this direction. There is no other option. You can
So,
also
but
say,
don't we have to use the road? Like,
huh?
do we use like the axis as the road that you have marked, or we use it from the point?
No, I said in the beginning, the standard xy axis generally means in a plane, the right hand side of the plane represents x and the top represents y. Okay, if there is a relative axis I wanted to discuss, then I would say something like this, like this is x and this is y. But for that I would not say the standard axis. I'll say in an axis system which is in reference to the road. That is how I will mention it. Okay, In that, I don't even need to break it into components, do I? Because the vector is anyway in the x direction, directly in the direction of the road. Okay, so in an axis system which is along the road, then I would simply say 5x 50x cap. Okay, there's nothing more to it. Okay, because the vector itself is along the road. So if you define an axis system where the x is along the road and y is perpendicular to the road, then it defeats the entire purpose. It just, I have to just say 50x cap, that's it. Okay, but I'm not saying it's not useful. Sometimes the reference along the road is also used in physics, but there it will be mentioned which reference. But if this is the standard reference system, always understand in your copy, right hand side represents the x-axis, top represents y, and a vector which is coming out of your copy represents the z. Okay, z is also not random. Like there are two perpendicular direction. One is coming out of the copy, the other one is going into the copy. Okay, so remember, the one coming out is the z-axis, going in is the minus z-axis. Okay, now the reason for that, again, I'll discuss towards the end of today's class. P vector here would represent, if this angle is 60, I believe this angle is also 60 degrees from geometry. The reason being alternate interior angle. So towards 60 will be cos 60. So this component here will be 50 cos 60. Okay, and the downward will be 50 sine 60. Okay, so your vector will be in the x direction, it will be 50 cos 60 is how much? It's essentially 25 x cap. Okay, now the other vector is coming down. Okay, and which is 50 cos sine 60. Sine 60 is root 3 by 2, that's 25 root 3 in the minus y axis. In the minus y axis. Okay, so that's why I felt like, oh, I think someone gave the correct answer also.
So I gave the correct answer.
Yes, one of you both gave the correct answer also. Few of you have given the correct answers. Yes, very nice. All, I think most of you have difficulty in the x cap and y cap only. Everybody got the same magnitude. Breaking into components was not the difficult part. Giving directions was the important part. Okay, so I hope everybody understood what mistakes they made, and I hope they don't make it in the future. Okay,
So
so
why do you
please,
put negative again? Like, how do you know it's negative?
opposite to y-axis. See, this is the y-axis. This is the y-axis. Okay, this direction was y-axis. This is what we chose. Okay, and when I broke the vector, if you look, if you look the vector component, one was along like this, and the other one was like this. Do you understand? Like one is 50 cos 60 was along the x-axis. This was 50 cos 60, and 50 sine 60 was coming down. Okay, hence it is minus y-axis. Does that answer your question? Yes, no, kuch to bolo. Okay, I'm going to repeat one more time with a different example, of course. Okay, now let us do an analysis like this. Let's say this is the entire coordinate system. Okay, x, y, this is positive x-axis, this is negative x-axis, this is y-axis, this is minus y-axis. Okay, now let's take an orange vector in this direction. Guys, tell me, what will be the components? Will it be both of them will be positive, or one of them will be
Both
negative?
positive.
Yes, very nice. So the orange vector, if I break it into components, one will be along x-axis, the other one will be along y-axis. Hence, both the components in this case, case 1, both will be positive. So you'll have something positive x cap, some positive y cap. Okay. Now let's imagine in the standard coordinate system a blue vector that is going like this. Okay. Guess this vector will have components in which two directions. Understand
Both
your vector
negative.
quantities will always can be broken down into components in two mutually perpendicular directions. There is no other way. Mutually perpendicular directions you have to break it.
Both negative.
Huh?
The blue one would be both negative.
Yes. So if the blue one, if you want to break it into two components, one in the x direction and the other one in the y direction, then you'll end up with a vector that looks like this. One vector will be in the minus x, the other one will be in minus y. So case number 2, the blue vector, I'll write it here. Case number 2, the blue vector here will have something minus x cap, and you'll have something minus y cap. Does this make sense? If it does not, please let me know.
Yes, sir. Makes sense.
Yes, no?
Yes, sir.
Okay, cool, cool, cool. Now, if I give you a last vector, which was the previous case, something like this, or something like this, okay. How do you break this yellow vector? Well, one
Positive and
will,
negative. Positive
huh,
x, negative y cap.
yes. So one will be along. You can also do it the reverse way. You can say, ki, one is coming minus y and it is going x. Okay. So no matter what you do, you'll always get positive x and then minus negative of y cap. Okay. Yes, Harshini, please ask. I think you raised your hand.
So this was a mistake.
Oh, cool.
Sir, I left the meet like 2 minutes ago. Can you tell me what happened?
Haha.
I left the meet like 2 minutes ago. Can you just repeat what happened?
Okay, I can repeat. But again, if this happens again, try to
Yeah,
hold
I'll
it
make
till the
sure.
lecture
Yeah.
ends. And because I'm gonna share the whole recording of today's class. Okay. Last time I had some recording issues. That's why I was unable to share the original video. But today's video will be there after the class. So let me repeat one more time. So okay, where do I start again? Okay, so let me erase this. Okay. Try to wait for the videos. Okay. So to answer your question, what I am saying is that if I have a vector like this in the first quadrant, okay, how do you take its component? Well, I have to go along the x-axis and then I can travel along the positive y-axis. So for the first case number 1, your vector A vector will be broken down into one positive x cap and one positive y cap, if that makes sense. Okay. Similarly, if your vector is in, let's say, the third quadrant, like somewhere here, okay, somewhere here is the then how do you break into components? One will be along minus x-axis and the other one will be along minus y-axis. There's no other way to break this. Okay. So when you break this into components, you'll have one minus x cap and one minus y cap because you're traveling opposite to x-axis. So this is minus x-axis, and then you're coming down. So that means that's minus y-axis. The question that we did in the previous one is this a vector in the fourth quadrant. Okay. In the fourth quadrant, to reach there, you have to go in the negative y direction and then positive x direction. So this particular uh, you know vector can be broken down into a positive x cap and a negative y cap. I hope that makes sense.
Yes, sir. Thank you.
Okay, let's move forward. Okay, write down the next topic for today's class. Okay, which is how do you represent, how do you go from algebraic to graphical? Okay, now we just studied if our vector was given in graphical format, how do you go into the algebraic format, right? Like a graphical format is given to you. This you can represent in some numbers like 5x cap plus 5 root 3 y cap. So this, what did you do just here? You took a graphical format and you converted into algebraic format. Now how do you do the reverse? Like for example, if I give you a random vector, a vector, okay, oh my god, a vector as, let's say, 3x cap plus 4y cap, how do you find out, the and we are going only in 2D. Okay, we're not gonna do 3D now, just now. Okay, 3D we will study in you will study in math. So for us, the only thing that we are going to most of the time we'll be dealing only with 2D. Okay, we'll not be dealing with 3D. So we'll not involve z cap in our discussion, because once you bring in z cap, the angles become difficult to analyze. And we can do that in our actual physics class. Like when I start teaching scalars and vectors as a part of physics course, then maybe I want to discuss a little bit of 3D also. But right now, no, I want to talk only about 2D stuff.
So
So
I
if I
have a
have
question.
yes,
So can we also use, instead of trigonometry, Pythagoras theorem? Will that work in this case?
yes, yeah, that's what I'm gonna use. Yes, definitely, that's what I'm going to use. Okay. So because these are standard direction and the angle between them is 90°, yes, Pythagoras theorem is the one that I'm going to use. Because when you say 3x cap and 4y cap, I essentially mean that I have to travel 3 meters along the x-axis, and then I have to travel, 4 meters perpendicular to it in the y direction. So if anyone asks you, "Ki, what is the length of the original vector right here?" Well, you're gonna use what? The Pythagoras theorem. You're gonna use the Pythagoras theorem. Okay. So I'm going to write like this and tell me if this statement makes sense to you. Mod of a is actually under root of the x component of a square plus y component of a square. Tell me if this makes sense to you.
Yes, sir.
Yes, sir.
Because the length of this green vector, the magnitude of this green vector will be under root of 3 square plus 4 square. Okay, which essentially means I take the x component of the a vector and the y component of the a vector, and I square them, add them, and take an under root. Does this make sense? Okay. Now that being said, I have given the magnitude of the graphical format. Now if you represent
This last statement, please.
uh, I have I forgot what the last statement was. Is it the statement ki I
Uh,
have represented
no, sir.
the
Can you explain like how it's ax square plus ay square again?
okay. So like what I mean by ax is that, like, for example, if I give you any random a, and there is let me turn off this auto.
Sir, you're on mute.
Yes, guys. Sorry about that. Uh, okay. Sorry about that, guys. I was trying to turn off my automatic shapes thingy, and then somehow I closed the whole meeting. Thank God. Okay, so I was saying ki, if I have a random vector like force vector, okay, and this has, let's say the force is acting in two directions, okay, 10 Newton like this, and I don't know, like 15 Newton downwards. Okay, what is the net force on this body? Well, you can use this. So it has an x component which I'm going to represent as fx. Fx is equal to 10 in the x direction. Okay, and then you have essentially 15 Newton in the minus y direction. Okay, or which I'm going to call fy, which is the y component of this force, and it is equal to 15 because it's given in the question as 15. How do you represent this as the original vector in the graphical format? Like, you'll have to show it like this. Okay, I actually made a little bit longer, so this is it. Okay, now in the graphical format the length has to be correct, right? The length has to be correct. If this is 10, this is 15, I need to find out how much length this arrow is. Now that you can find using the Pythagoras theorem, and you can see key under root of 3 square plus 4 square is essentially going to give you the original length. So here it will be under root of 10 square plus 15 square. If I write it in a general format where everybody can use it for future use, is this. Okay, under root of ax square plus ay square, where ax is the x component of the vector a and ay is the y component of the vector a. Does this clear your doubt?
Yes, sir.
Okay. Okay. Similarly, if I want to find out the direction though, If I want to find out the direction, do you remember every vector quantity? If I ask you what is a vector quantity, you cannot just say the magnitude. You also have to say the direction. How do you give direction in the graphical format, guys?
So by using the angle.
Using the angle. You forgot or what? We find out the angle with the horizontal x-axis. Okay, horizontal x-axis. This is the theta that we are usually looking for. Now, we already know 4 and 3. Can we use a trigonometric ratio to find out this theta? Well, I think tan theta will be the most appropriate.
Yes,
Tan theta is usually the perpendicular upon base. Yes. So it will be what? 4 by 3?
yes, sir.
Right. If I write it in the general format, can I write it like this? The y component divided by the x component.
Yes, sir.
Okay. I hope this makes sense. Okay. And if it does, then solve this. A body is acted upon by two forces. One is 10 Newton towards the right and 15 Newton towards the bottom. Find me the magnitude of this vector. Okay. And also the direction.
So you mean direction as in the quadrant in which it is, or
No, direction as in theta.
the angle theta? Okay.
Whenever I say direction in graphical format, immediately in your mind to say we are finding out theta, because in the graphical format the direction is given by theta.
So could you scroll up for 1 second, sir?
1 second is over. 1 second is a very less time. Ask for more.
Yeah, sir. Thank you.
A small survey. Please press F in the chat if you are from ITPL. There are 2 batches attending today's session. One is the ITPL batch. The other is actual normal online 11. So a lot of people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Excuse me, sir.
Yes.
Sir, I'm just a bit new to Centum Academy, so can you just clarify what IITPL stands for?
Oh, actually, what is going on is today two batches are attending today's session. Okay, one of this batch is the actual Centum Academy batch, which is not an integrated school course. Okay, it's after school program. ITPL is essentially a place where we have an integrated course with the NPS located there. So this is, I'm just asking how many of the integrated course students are here. Okay.
Oh, thank you, sir.
So I think close to 30 people are from ITPL. Rest of the 16, 17 people are from the after school program, I guess. Okay. So your timings might slightly change after the summer. After summer, schools will open for ITPL, so you'll have offline classes. Okay,
So,
cool.
a question.
Yes.
Like in the previous question, we found out that tan theta was 3 by 4. So what if we don't know the value of theta in that case? Like we know what the value of tan theta is, if we don't know
It's
theta.
okay. It's okay. It's okay. I'll tell you how. Okay. So first thing I know, the net vector, the net force will be actually in this direction. What will be the length? Well, it's very easy. The magnitude will be given by 10 square plus 15 square. Okay. Now 10 square is what? 100. 15 square is 225. So the length of this vector is under root of 325. No need to worry if you're not getting a
So
whole
that's
number.
5 root 13.
See what?
So this thing we can change it to 5 root 13 root 325.
Oh, you're telling me the value of root 325?
Yeah.
I don't know how much that is, but it is whatever it is okay. I made up the question on the spot. We are not expecting some really good values here. Anyway, let's move forward, and I want to find out the direction with the x-axis. So for that reason, I said tan theta is equals to the y component by x component. Okay, so y component is 15, x component is 10. So see, some people will ask, sir, should I put minus 15 here because it's in the reverse direction? Well, you can put, and it will give you a minus theta. But if you understand the angle that you will be getting is it will be in the clockwise direction using your own logic, then you don't have to use minus sign here. But if you directly put minus sign, your theta will also come negative. What does the negative sign imply? It means that usually angles are measured in the positive x direction, like in the anti-clockwise direction. The angle that you found is going to be calculated in the negative, in the clockwise sense. Okay, so this is going to be 5 times 3 and 5 times 2, 3 by 2. Okay, now from here, theta comes out to be tan inverse of 3 by 2. Now, this might be new for certain people. Okay, this is known as inverse trigonometry. If you have sine theta is equal to some value x, theta is equals to sine inverse x. Okay, so sine inverse is a function. Like for example, if I do it for sine 30 is equals to half. Okay, then sine inverse of half is 30 degrees. So this is the inverse function of trigonometry. This is tan inverse of 3 by 2. So you can write your answer like this. This is the complete answer.
Is that a negative 1, like on top of theta?
Yes, that's a negative 1. Sorry.
So what do you want to find the exact value? Then
you use a calculator. The tan inverse function is there in the scientific calculator. You press shift plus tab and you get tan inverse.
okay, sir.
So the magnitude of our vector is under root 325 newtons. And what is the direction? What is the direction? The direction is tan inverse,
3 by 2.
3 by 2. Clockwise, right? Clockwise from x-axis.
So tan inverse of 3 by 2 is just 3 by 2 tan, right?
3 by 2. No. This is math again. Please hold your horses. Inverse trigonometry will be taught to you. Don't try to find out the value right now. Tan inverse 3 by 2 is not 3 by 2. Let me actually find out. Let me just Google this out. You guys Google it out. Tell me.
Is it possible to calculate this on paper and not on calculator?
No, it is not.
Okay.
Guys, tell me what is the value of tan inverse 3 by 2. Google it out.
So how is it clockwise from x-axis?
Hmm?
How is it clockwise from x-axis?
From the diagram right here. It gives us the angle with the x-axis. No, you did see this here theta. The way we define theta was the angle with the x-axis. Yes or no?
Sir, but clockwise is negative angle, no, sir.
We got a negative value. No, I explained it. See, actually 15 Newton is in the reverse direction. So this is actually minus of 15. Okay. But I used my logic here. I said, I already know the angle is going to be in the clockwise direction. So why? Yes.
38.188459290.
Just give me two digits, dude. 2 digits and 1.
38.188.
38.1.
So in degrees or in radians, which one do we have to tell?
I think this is in degrees.
So I'm getting 36.30.
No, I feel like this is incorrect.
Sir, I'm getting it as 56.31.
No, that is correct. Well, do you know how I know 38 is wrong? Because I know tan 45 is 1. Tan 45 is 1 and I have 1.5 in my value. So this angle has to be greater than 45, no?
Sir, it's 56.31.
56. Okay, that makes sense. 56.3 degrees. Okay. Again, there's no way to physically find this, like physically on a piece of paper. You have to use your calculators to find it. Okay. But when you are given actual problems in exam, you'll not face these kind of calculations. Okay. No need to worry. I hope you understood the process. Process is more important. Now, I was going back to talking about how do I know that this angle is in clockwise direction? Well, theta was the angle with the x-axis, and in the standard case that we derived, it was calculated in the anti-clockwise direction, and this was +4 and +3. Hence, you could have put +3 and you'd have gotten an anti-clockwise angle that was equal to 37 degrees. Okay, tan inverse 4 by 3 is actually 47 degrees, 37 degrees. Okay, so that being said, I know my current situation is different. 10 Newton is acting to the right and 15 Newton is acting to the bottom. So the net vector will be actually in the fourth quadrant. So the angle that we are finding out is this. Okay, I hope you understood that. Now, if you plug in, see, I have used my logic here to say that tan theta is equals to 15 by 10, 15 by 10. Although this is actually not 15, this is minus 15, this is minus 15 y cap, right? Do you remember this? This is actually minus 15 y cap. So I should have put a minus sign here. If, and your answer would come out to be minus of tan inverse 3 by 2. What does this minus sign signify? Theta usually is measured in the anti-clockwise direction. When you get a negative theta, it means that your theta you have to measure in the clockwise. Now, yeah, if you understood that using logic, there is no use of sign. No need to use the minus sign. But if you want to just take like normal calculation, math calculation, just put in minus, and at the end just say the minus sign here represents the clockwise direction. I hope things make is it clear, guys? Guys, any doubt?
Yes.
Yes, understood.
If you have any doubt, feel free to ask.
So the answer will be written in tan inverse, right?
Yes, tan inverse. Let's move forward and let's talk about the next topic. Okay, addition of vector quantities. Well, we have studied to represent the vector in two different ways. One of them is the algebraic format, the other one is the graphical format, right? So that means when I'm discussing the addition of vectors, okay, I have to talk about both the representations, right? If it is represented in the graphical format, how do I add the vectors? If it is represented in the the coordinate or the algebraic format, how do I add them? Well, the first part of this question is really of this discussion is really easy, okay, and it's very intuition based. I'm going to actually ask you guys to tell me how do I add these vectors. Okay, so let's say I have some a vector which is given as, let's say, 4x cap plus, sometimes x cap can also be written as, now this you might have seen in your some of your textbooks, it can also be written as I cap, and y cap sometimes can be written as j cap, and z cap can also be written as k cap. Okay, no need to worry, these are just alternate symbols sometimes used for x, y, z directions. Okay, so I'm going to use the new system, 4i cap plus 3j cap plus 6k cap, let's say. Okay, I'm going to stick to 2D only, but just for this particular one example I'm going to take 3. Okay, let's take b vector as minus I cap plus 4j cap. That's it. That's it. Can anyone help me find out how much is a vector plus b vector? Please use your intuitions. Let your intuitions flow. Tell me, what should I
3i
do?
cap plus 7k cap plus 6k cap.
Yes, awesome. Okay, I told you in the beginning you can add vectors only if they're in the same direction. Okay, so yeah, how do I find out a vector plus b vector? Just add I to I, j to j, and k to k. Okay, so 4i minus I is how much? 3i. Okay, so I'll write like this, 4 minus 1i.
So
And then
when we write a plus b vector, do we just like put a plus b and then one arrow on top of both of them, or should we make two separate arrows?
no, we need to make two separate arrows. Like if you write this is what you're asking, right? Should I make like this?
Yeah.
Well, I don't think it's going to make much of a difference. Okay. But I think the most standard way of writing this is like this only. I've seen everywhere is like this only. Okay. What about a vector minus b vector, guys?
We follow the same thing.
Yeah, we follow the same rule. Can you give me the answer to this?
So 5 I cap plus minus j
minus
cap
1 j cap minus j cap minus 6.
plus
Plus
6
6
k cap.
Okay. So again, for people who did not understand, all I did was I took a vector and I subtracted all the values of b. So 4 minus minus 1 is 5, 3 minus 4 is minus 1, and 6 minus 0 is 6. Okay. So addition of vectors in the algebraic format is really, really easy. Okay. So this is what, this is the addition of vectors. The addition of vectors in algebraic form. And this is why we like to convert our vectors into the algebraic form, because addition is really, really easy. Okay, addition of the vectors is really, really easy. Well, how do you do it in the graphical format?
So convert it to algebraic and then do, sir.
That is one way, but there is also one direct way. If all we did was convert graphical format to component form and then always add, then I will not be writing a graphical format. I'll just say ki, do it yourself. But there is a direct way of doing graphical format also. Okay. Now, when in graphical format, usually the vectors will be given like this. For example, I am given a vector A vector, B vector, and the angle between them theta will be given to us. Okay. If they want us to find out A vector plus B vector, these are the three things I need to know. I need to know the magnitude of A, I need to know the magnitude of B, and what is the angle between these two vectors. Without these conditions, I cannot add two vectors. Okay. If I want to add two vectors, I need to know these three quantities. What is the magnitude of A, what is the magnitude of B, and what is theta. You can make a small note to add two vectors. Okay, we need magnitude of A, magnitude of B, and theta. But theta is not any random theta. Theta is the angle between the vectors. Okay, I hope you understood. Now, how do I find this? Now, this particular law's derivation also comes in exam. Okay, so this is something that you can pretty much note. Okay, well, first let us write down the statement. What is the statement? Okay, so the statement goes like this. If we arrange A vector and B vector as adjacent sides of a parallelogram, okay, if we arrange A vector and B vector as adjacent sides of a parallelogram, the length, or I will say the longer diagonal represents A vector plus B vector. The name for this is also resultant. Okay, we call the addition of A vector plus B vector the resultant of A and B. Okay, the resultant of A and B. Okay, so again, let me repeat the statement one more time. If we arrange A vector and B vector as adjacent sides of a parallelogram, the longer diagonal represents the resultant. Okay, now this particular statement is known as the parallelogram law of addition. Parallelogram law of vector addition. Okay, please write down this statement. I'll use this in derivation. Okay, please let me know. I'm going to ask you, what do I do next, and you should be able to answer. Okay, so this is the parallelogram law of addition. Let me move to the next page if everybody has written this. Okay. Okay, so what I'm going to do is I'm going to make a parallelogram. Let's say this is where I keep A vector. Now the orientation is very, very important. If you make this the first vector as B, then all the formulas will change. Well, especially the direction formula changes. Okay. Okay. Let's take B like this. Let's say this is B. And the angle between them is given to us as theta. Okay. How do I make a parallelogram out of this? Well, what I can do is I can make one parallel vector like this. I almost want to make it with a straight line. Okay. And this vector, I'm going to make it here. So this is essentially A. Can you tell me what this will be? This will be B. Okay. Guys, can you tell me how much is this angle right here? How much is this angle?
So it's
Theta.
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 It is equal to theta. How do I know this?
Corresponding
Parallel
angles.
Corresponding angles.
corresponding angles. These B vector and B vector are parallel to each other. A vector is acting as a transversal, and the two angles that I'm talking about are corresponding angles. Okay. Let's also name this particular parallelogram. Okay. Let's call this P, Q, R, S. Okay. And let's drop a perpendicular right here. Okay. Let's drop a perpendicular. Okay. Let's you know what I'm gonna use the same color thing. Let's say this is a perpendicular that I drop, and let's name this point here D. Okay. Now read the law and tell me what is A vector plus B vector. Which length is A vector plus B vector?
PR.
Yes, that is correct. Okay. I hope everybody understood from the statement that the longer diagonal represents the resultant. So here, right here, this length right here, I'm gonna struggle making this, I guess. Oh no, I did perfectly fine. This vector right here is actually what? This vector is actually A vector plus B vector. Tell me if this makes sense, guys.
So why can't it be QS?
Why can't it be QS? Because QS actually represents A vector minus B vector, and I'm gonna tell you why. In
So because it's a shorter diagonal of the two, that's why.
Is a shorter diagonal, and it represents A vector minus B vector. Okay, and I'm gonna tell you why. In when things get along a little bit more. Okay, and I'm gonna tell you about something called the triangle law of addition. Okay.
Sir, how do you know that PR is greater than FQ?
How do I know it is longer? Well, that is very subjective. Okay. I don't know how to answer that question. How do I know it's longer? Well, I can make this, and I feel like this is longer. PR is longer.
Pythagoras theorem, sir. You can use Pythagoras theorem by using RD to prove that it's bigger than PD. Then, since PR is bigger than PD and PS is a part of PD, then PR is bigger than PS, or something like that.
Okay. Let me
But you
wrap my
can't use the Pythagoras theorem because there is no
not 90-degree. It's not 90-degree. I don't think we can use the Pythagoras theorem here. Okay. But I think there's a way to do this using math. Okay. So I feel like this can be done using math. Like if I have a parallelogram like this will be the longer. This will be the shorter one. This will be the longer one. If I have a parallelogram like this again. This will be the longer one, this will be the shorter one. So depending on which kind of inclination you have, the longer and the shorter sides differ. Okay, you'll do that proof in a later date in your geometrical math class, but right now using visual inspection also, are you able to understand that PR is going to be greater than QS? This property about parallelogram you have to know. Like if you were tilted like this is going to be the longer side. If you are tilted like this, okay, this is going to be the further distance, because as it tilts more and more, this distance keeps on decreasing. Okay, this distance keeps on decreasing. Okay, and on the other hand, this keeps on increasing. Whoever has asked a doubt, is it clear?
Yes, sir, it's clear.
Okay. Now the next question is, how do I find out the length of PR? Because if I want to find out the vector PR, the resultant vector A vector plus B vector, I need to know the length of PR. Okay, but for that I need to analyze this smaller triangle right here. Okay, The smaller triangle right there is going to be SRD, which is a right angle triangle. Okay, and the length of the hypotenuse is B. This angle right here is theta. Bacho, jaldi, tell me what is SD. How much is SD? Towards theta is?
Cos.
Cos theta.
Cos.
So this is going to be
cos
SD is going to be B cos theta. What about RD? How much is RD?
B sin theta.
B sin theta. Please solve the triangles. If you are uncomfortable with just whatever I'm discussing right here, you can also solve the triangle. But there's a reason I made you remember this. We're gonna use it many times. Okay. So SD is B cos theta and RD is B sin theta. So okay, so all these values I have written. Now consider the triangle. Let me go a little bit up. Consider the triangle PRD. Tell me whether I can write PR square is equals to PD square plus RD square. Tell me if I can write this.
Pythagoras theorem.
Can I write this in the PRD triangle? Can I say PR square is equal to PD square plus RD square?
Yes, sir.
Yes, sir.
Okay. So PR is what we are looking for. This is essentially A vector plus B vector ka magnitude ka square. Okay. How much is PD?
A vector plus B cos theta.
Yes. So PD is actually A plus B cos theta. If anyone disagrees with me, please let me know. PD is actually PS. PS is how much? A, and SD. SD is how much? B cos theta. So hence from here P to D, the total length is A plus B cos theta. This is how much? B cos theta. How much is this? B sin theta. Okay. Plus B sin theta ka whole square. Please tell me if this makes sense.
Yes,
Okay.
sir.
Okay. So from here, please do the calculations. Find me how much is A vector plus B vector ka magnitude. It's going to be under root of something. It's going to be under root of something. Well, if you open the first one, it becomes A square plus B square cos square theta plus 2 times AB cos theta plus B square sin square theta. Is there something I can simplify here, guys?
B cos square, B
Yes,
square
cos square
theta
theta plus sin square theta is 1.
B square.
Yes, very nice. Most of you got it. If I take B square common from these two terms, I have sin square theta plus cos square theta, which is essentially 1. Okay. So that means this can also be written as what? A square plus B square plus 2 times of AB cos of theta, where theta is the angle between the two vectors. Theta
So
is
we
the
can write it as A plus B cos theta.
No.
no.
Because B doesn't have a cos theta, so you can't
Yep.
write it like that.
Okay, so it is very similar to A plus B whole square, but you have to understand there is 2AB cos theta. Okay, so don't confuse. Do not confuse. Okay, it cannot be written as A plus B cos theta ka whole square. Okay, because A plus B cos theta ka whole square will be A square plus B square cos square theta, no? But there is no cos square theta at the end. Okay, so this is something that you have to
So
memorize.
why is there a line above A and B? Shouldn't it be an arrow? Because we're representing vectors.
Haha, what?
So above A and B, there you just made a simple line. Should be an
Like
arrow.
with repeated use, you develop some sort of shortcuts. So this is the shortcut. You'll find that in some of your books also.
So then can we write it as A plus B whole into root cos theta?
Is this what you're saying?
No, sir, not whole square. A plus B whole into cos theta.
A plus
So
B.
A plus B is in bracket into root cos theta.
No.
Okay.
This is the standard formula you have to memorize. Is this too difficult, guys? Why are you trying to simplify this? It's easy. under root of a square plus b square plus twice of ab cos theta. That's it.
Okay, sir.
Okay,
So
please.
what are
R is resultant. I told you, A and B A plus B is also known as resultant. So you'll occasionally see capital R also used to represent A plus B.
Sir, can you once say the name of the law that you told before for parallelogram?
Parallelogram law of vector addition.
Okay. All good?
Yes, sir.
What else, guys? Any more doubts? Please feel free to ask. Okay. But is it complete? I gave you the magnitude. Is it complete?
So
do we
direction.
still need the angle?
Okay. We need the angle that is resultant, not A vector. See, I already know how much angle B makes with the horizontal x-axis. I know that. I need to find out this particular angle. Okay, so oops. I need to change this. Okay. I need to find out this delta right here. Okay, I'm gonna call this del. This is one Greek symbol that is used for angles. I think I should use phi. You have seen this angle more, right, in your previous classes.
Yes, sir.
Okay, so can you tell me how much is tan phi?
Theta by 2. No, wait. Phi is theta by 2. Is it, I think.
No, how do you know it's theta by 2?
If the parallelogram, wait, if the diagonal bisects.
No. Imagine I made a parallelogram like this, like one vector is very long, the other is very short. Okay, so this is the complete angle, and this will essentially be something like this. So this is in no way half of that. Okay, so if the sides of the parallelogram are equal, then only you can say the diagonal bisects the angle.
Sir, parallelogram opposite
Sir,
side.
we can use tan theta, right?
Yes, we can use tan theta. Again, focus on this triangle PRD.
B sin theta by A plus B cos theta.
Science prep has raised a hand. Yes, someone raised a hand also. Again, by accident or what? Okay.
No, sir, I wanted to answer. So
Oh, okay.
I think someone else already answered.
Okay, tan del is equal to B sine theta. That's cool. That's cool. RD by PD. Okay. So in this triangle PRD, tan del is why do we use this? Tan phi is actually equals to RD by PD. Why? Because tan theta is defined as perpendicular upon base, opposite side by adjacent side. So if I plug in the values, guys, tan phi will be equal to B sine theta by A plus B cos theta. Okay. Usually they do not ask tan phi, but if they do, this is what you have to do. Okay. I'm gonna put it at the bottom.
So then if we have to find phi, we'll again use the tan inverse of
Yes,
B
phi
sin-
would be phi would be tan inverse of B sine theta by A plus B cos theta. Okay. I hope this makes sense. Please let me know if you have any doubts.
So could you explain the tan inverse part? Or will we be learning that in math?
Okay. I don't think tan inverse part means like usually this part, right? See, I know that tan 60 is equals to how much? How much is tan 60?
√3.
Tan 60 is √3. Very nice. Okay. Now every particular function in math has its own inverse. Yes or no? Like for example, plus has minus, multiplication has division. Okay. Differentiation has integration. Now, what are these? This you will learn in 12th math. Okay. You will study in my class also when I will be introducing this. This is essentially calculus. But here trigonometric function also has their inverse. Like sine is sine inverse, cos is cos inverse. Okay. Tan is tan inverse. What does this quantity do?
Sir, but
Okay.
isn't the opposite of sine cosec?
No, you're confusing with reciprocal. There's a difference between reciprocal and inverse. Okay. Reciprocal of sine theta is cosec theta. Okay. But understand what inverse does. Like for example, 2 times 3 is 6, right? You understand this? 2 times 3 is 6. Now, if I take the answer 6 divided by 3 gives you what? 2. Okay. So that's why this is called the inverse function, because if you are using the result and one of the original functions, you are getting the, you are essentially getting the question from the answer. Okay. So 2 times 3 was the question, it gives you 6. 6 by 3 gave you the question, which was originally 2. Okay. So inverse function essentially means if you have, like, let's say we have a function and you plug in the value of 3 and you get 6. Okay. Then a function, the reverse function, the inverse function would be a function. When you plug in 6 in there, you'll get 3. I hope that makes sense. Okay. If you understood this inverse function, let's do a quick problem. If let's say x square is the function, okay, x square is the function. Can you tell me what is the inverse function of this? What is the inverse function?
Root x.
Root x. Very nice. Why? Because check this. If I put x equals to 2, my answer is 4. Answer is 4. Okay. So I need a function where if I plug in the answer 4, I get the question 2. Okay. So root x is the correct option here. Okay. So x square, like if x equals to 2, your function value is 4. If x equals to 4, your function value is 2. So this is why this is known as the inverse function. I hope this makes sense. Guys, does this make sense?
Yes,
Okay.
Yes, sir.
On the other hand, what is the reciprocal of x square?
1 by x square.
1 by x square is the reciprocal of this function, or I would say x raised to power minus 2. Minus 2 is the reciprocal of this function. Okay. So if we plug in 2, I get 4. If I plug in 2 here, I get 1 by 4. Okay. So it's not that I'm getting the answer out of the question. Okay. So if tan theta, like here tan 60 is root 3, then tan inverse of whatever, like some value, like here root 3 will give me 60. So do you understand the proposition here? So if you have any number like tan inverse of 99, this will essentially give you the angle that was associated with it. Okay. So tan inverse of 1. Tell me how much is tan inverse of 1, guys?
45.
45 degrees. Okay. So that's why the whole tan inverse function. Okay. So here, what does tan inverse represent? See, if you do b sine theta upon a plus b cos theta, you'll essentially get a number. Okay. You'll get 1. You'll get root 3. You'll get 1 by root 3. Okay. Or probably you might get 0 also. So in that case, what do? You get whatever value you get, you take a tan inverse of it. Okay. So tan inverse of root 3 will give you 60. Tan inverse of 1 by root 3 will give you 30. Tan inverse of 1 will give you 45. Okay. So those sort of things. Is your doubt clear? Or would you like to ask anything else in this?
Sir, I have a doubt.
Yes.
Sir, so if we take sine as f of x and sine inverse as g of x, so since they're inverse of each other, so would f of g of x be equal to x?
What? One more time, please repeat your question a little bit louder. I'm unable to hear you.
Yes, sir. So so if we take sine as f of x, any function sine as f of x, and sine inverse as g of x, so would f of g of x be equal to x because they are inverse of each other?
Oh my God, you're too much into math, dude. Wait, fx is you're saying sine x?
Yeah, and g of x is sine inverse x.
Sine inverse x. Okay, now you want to do this fogx?
Yes, sir. So it would be x, right? Because they are inverse of each other.
Yes, but this is way out of our discussion right now. Okay, so try to keep your questions very relevant to this. I feel like you are a foundation student when you have done all of this before. Okay, so try to limit your questions to the topic itself. I like that you are asking this. This is a very how can I say, very good question, but it is too much way out of this. Goes beyond
If
physics.
we say that tan 0 is not defined, so would tan inverse 0, wait, yeah, tan
Tan
inverse
0 is 0. Tan 90 is not defined.
Yeah, so would the inverse also be not defined?
No, like you will have, what this means is that tan inverse of, you cannot put any value here that will give you 90 degrees.
Okay.
Okay. This means ki tan of 90 is not defined means tan inverse of not defined is 90. Does that make sense?
Okay, yes.
Okay, so that means you cannot put any number whatsoever number you put, you'll never get 90 out of this. Okay, anything else? No more doubts?
Does that mean like tan inverse of 90 does not exist?
Tan inverse of 90. Tan inverse of 90 it does exist. It will give you some angle, but it is not equal to 90 degrees. I hope that makes. I hope you're understanding. We are dealing with two quantities here. We're dealing with an angle and an answer here. Answer will be a real number, not an angle. Okay. So, like for example, sine tan 45 degrees is 1 being the real number. But in the reverse or in the inverse function, tan inverse of 1 is the real number, gives you an angle. Okay. So I want you to reframe your question if you understood. Okay. I was saying that tan inverse of any particular number will not give you 90 degrees is what I was saying.
Yes, so this function does not exist. It does not exist.
No, it does not. Tan inverse of any number is never going to come out as 90 degrees. You can take your calculator, put as big a number as you can. Your answer will always be 89, 89.9, 89.99999, but it will never be 90.
Okay, sir. So that was my question.
Okay. Okay. So that being said, let's quickly do one question, and after that we'll take a small break. Our classes will run up to 12:30, I believe. Okay. So give me 1 second, quickly checking the break timings here. Do a question in the meantime. Okay. So there is a body which is two forces are acting on it. One force is 10 Newton like this, and the other force is I don't know, 20 Newton like this. And the angle between them is, let's say, 60 degrees. Okay. So tell me, what is the net force? How much? So this is F1. F1 force is 10 Newton. F2 force is 20 Newton. Tell me how much is the resultant. Okay. Try this.
So can we put the answer in the chat if we got it?
Yes, please put your answer in the chat. Okay, let's check the answer. I got a few answers. Yes. So the resultant ka formula is under root of a square plus b square. So that means for us, a and b are 10 and 20 respectively. So 20 is 10 square plus 20 square plus 2 times of 10 into 20 into cos of 60 is how much? Cos of 60 is half. Okay. Now that is essentially 100 plus 400 plus 200. Okay. So your answer will be 700. That is correct. 700 root 700 is your resultant. That comes out to be 10 root 7 newtons. Don't forget the unit. Your resultant magnitude is 10 root 7. However, how much is the angle? Okay. Now understand A and B. that we have defined is essentially subject to perspective. Now, for example, if you take this as A, then this is the angle we are finding. Okay, this is the angle we are finding. If you take the other one as A, then this will be the angle we were finding. Okay, so I'm taking 10 Newton to be A, 20 Newton to be B, and this is the phi I'm looking for. Okay, so resultant is in this direction, let's say. So tan phi is going to be B sine theta. Okay, B sine theta means 20 sine 60 divided by A, which is 10, plus B cos theta. So B 20 into half. Okay, notice to find out angle with the A, your numerator will start with B. Okay, phi is the angle with the A. Just notice that. Just remember that. Phi is the angle with A, because in our original derivation, if you check, the phi that we have found out is with angle A. So please notice that if you are finding out phi A, then that is the angle with A, and your numerator will be B sine theta. So it starts with 20 root 3 by 2 divided by 10. So if you solve this, can you tell me how much we are getting? Tan phi will be how much if you simplify?
So tan phi would be root 3 by 2.
Are you sure?
So is it 10 root 3 by 20, which is basically 1 by 2?
That's why I said 1 by 2 root 3 by 2.
So let's just get rid of all the zeros. So you get 2 root 3 plus 1 plus.
So is it root 3 by 2?
Wait. 2 by 2 is 1.
Say 60.
Is this?
So isn't tan phi root 3 by 2?
No, it's just root 3. No, I'm getting root 3. See,
No,
if I
sir,
can.
You forgot the half, sir. It's
where is the root 3 by 2?
3 by 2, sir.
So you
20
forgot
into
Root 3 by 2.
denominator.
So I actually cancelled out this and this, and I get root 3 in the numerator. In the denominator, I get 1 plus 1. Yeah, root 3 by 2 is the correct answer. So how much is phi, guys? Phi is
Tan inverse root 3 by 2.
tan inverse of root 3 by 2. How much ever is that value? I know that value is going to be less than 45 because root 3 is 1.7. So 1.7 by 2 will be less than 1. So that means the angle will be less than 45 degrees. Okay. So what will I say? How will I finally present this answer? I'll say the net force is 10 root 7 newtons, and it is acting at an angle of tan inverse root 3 by 2 from the 10 Newton force. Let me repeat my answer one more time. Please pay attention. The net force acting on this block has a magnitude of 10 root 7 newtons, and it is acting at an angle of tan inverse root 3 by 2 from the 10 Newton force, or from F1. Okay, so that is how I will answer my question at the end.
So can you repeat once more, please?
Okay, I'll say the magnitude of the resultant is 10 root 7 Newton, and it is making an angle of tan inverse root 3 by 2 with F1 force, or with 10 Newton force. Please understand it and write it in your own words. I'm not trying to dictate here. Okay. Please
So you
write
can
it.
also convert it into a parallelogram and find the length of the longer diagonal, right?
You can, but what's the point of derivation then? Every time we'll do the derivation or what? All the derivation is to give you a final crisp result, which is essentially under root of a square plus b square plus twice ab cos theta. If every time you had to make this parallelogram, then it would be very lengthy. Your calculations will be very, very lengthy, right? You have to do geometry all so many times. So that's the whole point of this derivation key. I taught you this derivation because I need you to understand where it came from, but I need you to also understand or remember the formula, so that if the question comes, you can easily use this formula to find out the the resultant between two vectors. I hope that makes sense.
So for finding out the angle, so like the I don't know, the fin angle, so we always use tan. Like we can't use sine or cos.
See, if you want to use cos, let's say, you'll need the length of the hypotenuse, right? Yes or no?
Yes, sir. But
Yes,
we're
I
finding
need the hypotenuse. So that means if, for example, the question was only asking direction and not the magnitude, that means you'll have to anyway find out the magnitude, and it increases the number of steps. But having finding out tan phi is beneficial in the fact you don't need the magnitude to find out your direction. Okay,
Oh,
it's
okay.
independent of the magnitude of your resultant. Okay, so every time the question gives, it's not necessary that you find out the resultant. If they're asking only the direction, you just give the direction like that. Okay, let's take a short break here. Okay, let's resume the class at 11:05. Okay, it's a short break. Fill your bodies with water and food. Okay, and we'll be back at 11:05. The classes will run only up to 12 today. Okay. And I think it was a miscommunication, but as I communicated by 12, so I have to end by 12. Okay, so next time on we'll try to extend it by 12:15, because a 15-minute break would mean your class shortens by a duration of 15 minutes. Okay, so with that, go enjoy your break. We'll meet in 5 minutes. Welcome back, students. Okay, so just to recap, what we did today is scalars and vectors we defined. We resolve the vectors, like if graphical format of representation is given to us, how do you resolve the vector into component form is what we studied. Then we studied how do you add the vectors in both graphical format as well as the algebraic format. So algebraic format addition is really easy. All you do is add x to x, y to y, z to z. Okay. Whereas if you want to add two vectors which are represented in the graphical format and the angle between them is given to you, then you go under root of a square plus b square plus twice ab cos theta. Okay. And the angle tan phi that the vector makes with the vector a is given by b sine theta upon a plus b cos theta. Okay, so this is the formula. We did one question on it. Okay, so tan phi is tan inverse of b sine theta by a plus b cos theta. Okay, this is the formula you have to use. So and also remember the formula. I'm going to ask random people the formula next class. Okay, so come prepared for that. Now that you have understood how to add two vectors, next operation that we are going to discuss is the multiplication of vectors. Okay, the multiplication of vectors. Okay. Now, the curious thing about multiplication of vector quantities is that there are two types of multiplication. Okay. Now, in math, you might have understood, or you might have seen there are two symbols for multiplication. 2 multiplied with an x sign, 3 gives you 6. But you also do 2.3 as also 6, right? So in math, both these symbols mean the same thing because we are multiplying two scalar quantities, and scalar multiplication is taught in, I don't know, first standard, second standard. By then you are already memorized up to 10 scalar multiplications. Okay, and it essentially means the same thing. Okay, give me 1 second. Yes, sorry about the interruption. I was getting multiple calls for someone. I thought some emergency. Turns out someone wants to sell me something. Okay, so 2 times 3 is 6. 2.3 also 6. In scalar multiplication, which has nothing to do with direction, both these multiplications are essentially the same thing. Okay, but when you are multiplying two vector quantities, depending on what result you want, you have to use two sets of multiplication. The first is known as a scalar multiplication. Okay, the first type of multiplication is known as the scalar multiplication. Okay, and it is represented by the dot. So a dot b is essentially you are multiplying a vector to b vector using a scalar multiplication. Now, why do we call it scalar multiplication? Although you're multiplying two vector quantities, is because when you multiply two vectors using this particular type of multiplication, you get a scalar result. Okay, so you are multiplying two quantities which direction. When you multiply them, you get an answer with only magnitude. There is no direction to it. Can you give me an example of something that you have done similar in your previous classes? Multiplying two vector quantities to get a scalar value. Guys, what is the formula for work?
Work, sir, work.
Yes.
Force into displacement.
Yes. Formula for work, which is a scalar quantity, by the way, and it was defined in the first class. Okay. Work, power, and energy, all these three quantities have the same unit, joules, and it does not have any particular direction. Okay. So in scalar multiplication, you are multiplying force, which is a vector quantity, and you are multiplying displacement, which is a vector quantity, but you're getting a scalar value which has no direction. Okay, so that kind of a multiplication is known as what? Scalar multiplication or dot product. This is also known as dot product. Okay, The second type of multiplication is known as the vector multiplication. This is known as the vector multiplication. Okay, and you represent that using the x sign, a vector cross b vector. Okay, so this is also known as the cross product. This is also known as the cross product. So take a wild guess and tell me what will be the result of this multiplication. Will it be a scalar quantity or a vector quantity?
Vector.
Scalar.
No, it will be a vector quantity. The first type of multiplication gives you a scalar answer. Okay, this gives you a vector answer. Hence the name vector multiplication. Okay, so multiplication of vector can be done in two ways: dot product and cross product. If you do the dot product of two vectors, you get a scalar answer. If you do a vector product of two vectors, then you get a vector answer only. Now that example will be r cross f. R is essentially position or displacement, and you're doing a cross product with force. This will give you a quantity known as torque. This is known as torque. Okay, so notice the similarity here. The same two-dimensional quantities, force and displacement, when you do dot product, you get work. But if you do the cross product, you get a vector quantity torque. And do you know what torque is? Can someone let me know if what is torque?
Moment of force.
Turning effect.
Essentially, what force is for linear motion, torque is for rotational motion. So it is the cause of rotational motion. If you apply torque on something, it will rotate. Okay, it will rotate about its axis if you apply torque on it. Okay, so the same two quantities. This is position, this is displacement. If you do the dot product, you get work, but if you do cross product, you get a vector quantity. Okay, so that is the difference between them. So multiplication itself has two ways. So throughout our lecture, we'll be doing four things. Okay, multiplication.
Could you go a bit up for once?
I'm unable to hear you. Please say it slightly
Could
loudly.
you go a bit up?
Could you?
Go a bit up. Can you scroll up?
Oh, scroll up.
Yeah. Thank you.
Okay, so this is the lecture structure for the next 45 minutes. I am going to discuss multiplication, but multiplication has two types: dot product and cross product. So you have to learn dot product in the graphical format, then in the algebraic format. Then you have to learn cross product in the graphical format and the algebraic format. So we'll do four parts. So part number one will be graphical dot product. I hope that makes sense. Graphical dot product means you're going to do the dot product where you will get a scalar answer, but you are doing in the graphical form. Okay, so again, this is not something we have to analyze too deeply. The definition is very, very simple. Okay, everybody has copied this?
Yes, sir.
So just a minute. Yes, sir.
Okay, so let's go and start our discussion. Let's start our discussion. So the first part will be what? This is going to be in the graphical format. This is going to be in the graphical format. And we are going to do scalar product, or I'll write dot product. In brackets, I'll write scalar product. Okay. So you'll be getting quantities without any direction. You'll start out with quantities with direction, but in your answer, you'll get quantities only with magnitude. There will be no direction associated with it. Okay. So if I quickly talk about this, guys, graphical dot product will be something like this. So in the graphical format, both the vectors will be given to us, and the angle between them will be given to us as theta. Okay. So the definition for dot product is something like this. A vector dot B vector is given by magnitude of A, multiply that with magnitude of B, and then you take cos of the angle between them. This is how it is defined. Okay, this is how the product is defined. Please do not ask me for the derivation. It will be done in math. It will be done in math in your three-dimensional coordinate geometry in 12th class. Do not ask me for the proof, but this is something that you have to remember. This is how you have to do it. Okay. Now, let me ask you a few questions. If this is the case, if two vectors are in the same direction, what will be the dot product?
Only the multiplication.
Only the magnitude, product of magnitude.
Okay. Like for example, A vector dot A vector. What will be the answer? Magnitude ka square. That's it.
Yes.
Because you essentially, you know, ki A vector and A vector, both of them are in the same direction. So cos 0. Okay. If two vectors are in the same direction, then theta will be 0 and cos theta will be 1. Okay. So this part of the you'll just multiply the magnitudes. Okay, you'll just multiply the magnitudes. If the two vectors are in the same direction, theta between them will be 0. What if, you know the next part, right? I think you can guess. If two vectors are
Opposite direction.
Yes, if two vectors are perpendicular to each other. Tell me how much is theta? 90. How much is cos theta?
0.
0. Okay. So that means if what will be A dot B will always be equal to 0. Okay. So this is the beauty of a dot product key. When you have a dot product, if the vectors are in the same direction, then you just multiply the magnitudes. Okay. But if they are perpendicular to each other, your answer will be 0. Does that make sense?
Yes, sir.
Okay. So this is how. And what will be the direction of the answer? What will be the direction of the answer? No direction. This is what? A scalar product. Okay. Work has no direction. Okay. So like for example, if I do 10 joules of work and I do minus 10 joules of work, it doesn't mean ki the work done is happening in the negative direction. It's like saying ki 10 degrees centigrade and minus 10 degrees centigrade are in opposite direction. 10 degrees centigrade in this way, minus 10 degrees centigrade in the other way. It doesn't make sense. Okay. So you do not associate. In vector quantities, it means direction, but in scalar quantity, it just means the absolute value is negative. It doesn't mean anything. Okay. It doesn't mean that the direction is opposite. I've seen people say ki ha, work done is in opposite direction. That statement is wrong. Okay. So I hope you understood. Let's quickly do a question on this. Like, do you know the trolleys that we carry in the airports? Like, this is how it goes. Okay. So let's say this is one of the trolleys and you are applying a force of 50 Newton like that. Okay. And the trolley, you know, it doesn't fly away. It goes along the road, and it's, let's say the displacement is happening in this direction and that is equal to 10 meter. Okay. The angle right here, let's say, is 45 degrees. So find out what is the work. This is the force vector. This is the displacement vector. Find out how much is work. Guys, find out how much is work.
√2.
Yes, sir.
How much?
250 √2.
250 √2. Okay. Okay, let's check. Work done is given by the dot product of force and displacement. Okay, if you didn't know this, then we'll teach you again when I'm teaching work, power, energy. That's the 4th chapter in physics. Okay, so force dot displacement. Now force is now how do you do dot product? The magnitude of force, the magnitude of displacement, and cos of theta, the angle between them. Okay, the angle between them. So that means I plug in the value of force, which is 50, multiplied by, I tend not to use the X sign because in physics it means different sort of multiplication. 50 into 10, and cos 45 is 1 by √2.
So can we use dot here, like instead of multiplication sign? You can use that.
I would prefer to use the dot sign. Okay. So this essentially is 250 root 2. Okay, this is equal to 250 root 2. So rationalizing is something like the student has done rationalizing. He multiplied root 2 in the denominator and the numerator. You can also say 500 by root 2 means the same thing. Yes, anybody has any doubt in this? Okay. So okay, let's move on to the next part of the discussion if you're done with this. Okay. Tell me the second part. What will I do in the second part?
Algebraic dot multiplication.
Yep. I hope I'm not going any faster than you can understand. I am covering a lot of ground here, but that's because I'm not going into the depth of things. Okay. So don't start studying from a book and be like, sir, this is not taught, this is not taught. It will be taught. Okay. Right now, I'm just giving you the introduction because this is a bridge course. I want you to be, knowledgeful enough to start actual 11th. Okay. So this is like a preparatory course for your 11th standard. Okay. So I'm giving you the basics because these basics are going to be required in a very long run. Okay. So that you don't feel a lot of jump. So if you do start using a book to solve problems, understand that the lecture in class is not complete. Okay. So if you get some extra stuff in the book, just take it and try to understand it. If you are not able to understand, don't panic. Okay. It will be taught in class. Till then, whatever you can, you do from that book. Okay. So let's move forward. Algebraic dot product. Algebraic dot product. Okay. Or I would say it's the dot product in the component form. Okay. So in this scenario, what happens is your vectors are given like this. A is ax I cap plus ay j cap plus az k cap. So this ax is essentially a number that is representing the x something in the x cap. So this ax may be 3, 4, 5, something like that. B vector, let's say, is some bx I cap plus by j cap plus bz k cap. How do you do A dot B? Anyone has an idea on how to do A dot B?
So trinomial multiplication. Like the way you multiply 3 terms in algebra.
Okay, so yeah, that's good intuition. Let me ask you this, all of you. If I have something like this, A plus B multiplied by C plus D, how do you usually do it? Let your math intuition kick in here.
Yes. A into C plus D plus B into C plus D.
Very nice, very nice. You multiply A to C, and then you multiply A to D, then you go B to C, and then you go B to D, right? This is what we do. That's what exactly what we are going to do here. I'm going to arrange it like this: AX I cap plus AY j cap plus AZ k cap, and then dot product it with BX I cap plus BY j cap plus BZ k cap. Okay. So that means the first term that I'm going to multiply. Oh, before that, can you tell me how many terms should I get in this multiplication? Like total, what is the maximum possible number?
9.
9, right? Because you multiply the first term with the 3, second term with 3, third term with 3. So 3 3s are 9 different terms. But let me tell you the good news. 6 of these 9 terms are going to be 0. Can you guess which ones? 6 of these 9 terms are going to be 0. Can you tell me which terms? Think and answer. And I'm going to do this. I'm going to write a small hint on top. Come on, guys. You can do this.
I cap and J cap, like AX I cap, BY J cap. And
Yes.
then
So in short, whenever you are multiplying two different directions, because you understand IJK, XY cap direct, XYZ directions are mutually perpendicular. X is perpendicular to Y, y is perpendicular to z, z is perpendicular to both x and y. You do understand this, right, guys?
Yes.
Okay, so every time you're multiplying a quantity to something else, like if I'm multiplying ax to by, or if I'm multiplying ax to bz, my answer will be 0. Why? Because I'm multiplying x direction to y or z, which is perpendicular to it. Okay, and we know by the definition of the dot product is that cos 90 is equal to 0. So whenever you do dot product between two vectors which are perpendicular to each other, my answer will always be 0. Does that make sense to you guys? Let me know if it doesn't. Okay, so the three terms that I will actually get are simply ax bx plus ay by plus az bz, and that's it. These are the three terms I'll get. Anything else is just gonna be 0. Okay, so you can multiply x to x, y to y, and z to z, and you will get your answer. Okay, let's do a problem and things will become more clear. Let's say I have force given to us as 3x cap minus 2y cap plus 4z cap, and then your displacement that was created because of this force, let's say, is x cap plus 2y cap minus 8z cap. Okay, find me the work done. Tell me how much work done has happened.
So is it 3x cap minus 4y cap and
minus 12, minus say 32 z cap.
4z cap?
So is the answer minus 39?
Okay, whoever is giving me this answer, do not forget we are doing a scalar product here. Why does your answer have directions? When you're saying 3x cap, you're saying this has a direction. 4y means it has a direction. Why am I getting a direction in a scalar product? Dot product is also known as a scalar product.
So will it be negative
Minus-
of 33?
Yes, sir.
Yes. Okay. So dot product is a different name for this, is also the scalar product. This is also the scalar product. Okay. So whoever did this, made this mistake, they are multiplying the correct set of numbers. They are multiplying 3 times 1 is 3, but they are also associating a direction to it. Okay. That should not happen. These are scalar numbers. When you do a dot product, you do not get a vector quantity, you get a scalar value. So this is 3. From the first multiplication, I got 3. Next multiplication, I got minus 4. And in the next multiplication, I got, yes.
So sir,
Okay.
when we add these, we get minus of 33.
Minus 33?
Yes, sir.
Okay. So work done is minus 33. Minus 33 what? Minus 33 joules. Okay. Does this mean work done is happening in the opposite direction? No, it just means the absolute value of work done is minus in negative value. Okay. Work done is a scalar quantity. The direction does not, it does not have a directional sense to it. Does that make sense?
Yes, sir.
So how does the x cap, y cap, and like z cap get cancelled when you're multiplying?
Do not get cancelled. This is defined. This is defined in a way that when you are multiplying two vector quantities, you're getting a scalar number. The direction did not get cancelled. It is because of the multiplication is defined in a way where you're multiplying two vector quantities to get a scalar value. Hence, the there is no direction at the end. Does that make sense? Okay. So when I defined, see, it's like this. You had vectors with you. Okay, you had vector quantities with you. And when you multiply two vector quantities, that can have physical significance or it may not. Okay, like for example, if I multiply force to, let's say, I don't know, some electric field. Okay, you know there is an electric field vector. It's a vector quantity. Force is a vector quantity. Okay, magnetic field is a it's a vector quantity. It's not that you multiply two vector quantities and suddenly it start making sense to us. Like for example, force multiplied by electric field. It does not make any sense. Okay, but there are certain combinations, like for example, force into velocity. If you do, it gives us a physical quantity that has sense to it. Okay, it has physical sense to it. Like when you multiply force into velocity, you get power. which is a real quantity that you can measure. Okay, so that but when you notice this, you understand, okay, I have a sort of vector quantity getting multiplied to another vector quantity, and the result is supposed to be a scalar quantity. Okay, that is when mathematicians define two kinds of multiplication. Okay, they define ki if you have two vector quantities being multiplied in a sort of dot product manner, okay, that is when you get a scalar answer that does not have an answer, that does not have a direction. And when you multiply this using a cross product, you essentially end up with, well, it doesn't, again, see, f cross v, it doesn't mean anything. Okay, r cross f means what? Okay, that is a vector quantity that again makes sense. So don't think of this like see, the difference between math and physics is big is essentially the part where math, anything is possible. Okay, even minus, this is possible. This is what? This is an imaginary number. This is I. This is imagine. This, even this is possible for them. Okay, but for physics, that thing has to make real life connections, only then that will be valid. I hope you understand.
Yes, sir.
Okay, so everything is related to real life, and the more you study physics, the more you understand the significance of what we are doing right here. But right now, if I try to explain, you'll just leave the class probably. Okay, so let's continue. So I hope everybody understood how to do. Again, we are learning only the tools in the first few classes. We are not learning actual physics here. We are learning the tools to learn physics. So I hope if next time, if I give you some vector and the second vector, and if I ask you to do a dot product, you have to remember that I will just multiply the x components, y components, z components without giving a direction at the end, and I'll add all this value. Okay, so just write a small note in your own words what you just did, because you'll forget. I know you'll forget. Okay, so the only thing that can prevent you from forgetting is writing a note on exactly what you understood by yourself, and you revise that at regular intervals. That is how you'll remember. Otherwise, you'll forget. It's a fact. Okay, so you multiply x to x, y to y, and z to z without any directions, and then you add it. Okay, so that is algebraic dot product. Can you tell me what should I do next?
Sir, graphical cross product.
Yes, the third one is going to be graphical cross product. Okay, graphical cross product. Now this is going to be a little bit hands-on, so I need you to essentially be very active for the next 15 minutes. Okay, so whatever you're doing, if the phone is, I don't know, lying somewhere, this is, hello guys, this is very important. Okay, this is the most important part of this lecture, the graphical cross product. This is going to be really I think this is the most difficult part to teach in an online class. This is the most difficult part to teach in an online class because of the sheer fact that this is a three-dimensional analysis. This is going to be a three-dimensional analysis, and I'm not there with you in the room. Okay, so the next best thing that we can do is I need you to focus on my screen as well. Like occasionally, what I will do is I'll unpin this particular presentation, and I'll pin my video going there. Okay, so I'll try to use papers and everything to try to represent what I'm doing here. Okay, so in graphical cross product, or what we will again have is essentially two vector quantities. Okay, so a vector like this, b vector like this, and the angle between them is theta, let's say. Okay, theta. So a cross b is defined like this: a ka magnitude, b ka magnitude, and then sine of theta. Sine of theta. Okay, tell me whether this answer is correct. I need everyone to be active. All 44 people, please be active. Okay, is this answer complete?
No, it doesn't have a direction.
Exactly. I gave you the magnitude. Magnitude is the easy part. All you do is take magnitude of A, take magnitude of B, and do sine of theta. Do sine of theta. Okay. And doing sine theta is not a big issue. Taking the magnitudes of A and B is not big an issue. The issue is this: finding out the R cap. R cap is any general direction where the answer is going to form. Okay. Answer is going to form. Okay. So for this, finding out, write down the next heading: finding R cap using right hand thumb rule. Right hand thumb rule. Right hand thumb rule. Let me write this. Let me write this down. Right hand thumb rule. Very nice. Okay. Now, what is right hand thumb rule? Do you remember in 9-10 standard you have studied?
So it's used to determine the direction of current, right?
There was the
So basically, it's for we use the right hand thumb rule for, like she said, for determining the direction of the magnetic field around the current carrying conductor.
Yes, that is true. Srishti, what do you wanna? How do you wanna say it? You're muted. Yes.
It's the same.
Oh, it's the same. Okay, cool. So yeah, whenever you are answering, try to raise hands, because some of you are doing it, some of you are directly answering. So it's unfair for the ones who are raising their hand. Okay, so try to raise your hands and pick one by one. We can say. So yeah, fine. Our right hand thumb rule is much more than current and magnetism. Okay, uh, it's a universal sort of multiplication. The reason you are using right hand thumb rule is because in magnetism we use cross product. Hence, we were using the right hand thumb rule. Okay. Yes, Fanak, sorry.
No, so that was a mistake. Sorry.
Please don't do this.
Yes,
Okay.
sorry.
So yeah, the right hand thumb rule is a consequence of the cross product. Okay. And because the force on a moving charge is actually given by velocity into cross magnetic field, that is why Fleming's right hand and left hand rule were valid there. Okay. Fleming's left hand rule and right hand rule were valid there. But whatever you studied in 10th standard and 9th standard regarding Fleming's rules, please erase all of it. That's all bullshit. Okay. What you have to remember is one single formula, which is the right hand thumb rule. Okay, there's no, like, if there's a minus sign in front, you just change the direction to it. There's no need to apply left hand rule, right hand rule, right, like I don't know, don't involve your legs also. If they want, they can use legs also nowadays. Okay, do not involve any of your other limbs other than your right hand thumb rule. Lefty people, be very careful. Your dominant hand being the left hand, you'll try to do this using your left hand. Stop, like, try to stop it. Okay, this rule will only be valid if you're using your right hand. Okay, so the process is very simple. I'm gonna write it down. Okay, so what you do is there's two ways of doing this. Whichever is clear to you, you follow that one. But whatever you start following, you just follow only that. Don't just choose one in the beginning and you do it forever. Okay, otherwise, again, I've seen people getting messing the direction up so many times, and the only reason is that they know a lot of different conventions and they confuse between them. Okay, so just follow one convention and then follow it throughout your life. You'll never be confused. Okay, unless you start teaching physics, then you should know all the different processes. Okay, find R cap using right hand thumb rule. Okay, so the right hand thumb rule goes something like this. Right hand thumb rule. So point all your fingers in the direction of first vector. Okay, this is the first step. Second step, curl your fingers along the second vector. Third step, stick out your thumb stick out your thumb, and that is the direction of your product.
So, sir, does that mean that the direction of the product is going from outside to the outside of the paper?
Yep.
Okay.
If you're doing a certain product, that is that
Okay.
I'll talk about. But I just need you to write down a few things first, and then only I will talk about more. Again, there is another variation of right hand thumb rule. Arrange thumb, pointy, and middle fingers in 90 degrees to each other. Okay. Second point, index, we call the pointy finger index, right? Yeah. Index finger is first vector. Middle finger is second finger, second vector. Okay. So if you're confused, what is this? Then this is the, I don't know how to make a hand. Okay, so this is the this is the pointy finger I'm talking about. Oh, I have started a really bad. I don't think I should make this. If I make the middle finger, I think I will, I don't know, get suspended or something. So make middle finger in your copies yourself. I'm not gonna make it. Okay. And I hope everyone in the class know the thumb. Okay, everyone knows the thumb. You know what? I'm gonna erase this also. Okay, so the thumb is the product. Okay, so this is what you have to. If you, when you are done writing this, please let me know. Then I'll start explaining all of this.
So for the second one, so is it like the left hand thumb rule? How you keep your hand similar to
No,
that?
no, no, no. Name itself says right hand thumb rule. Never will we mention left hand in our life.
No, sir, right hand thumb rule. But then, do you have to? You're saying that you have to keep them all 90 degrees to each other. So it looks like how you do the left hand thumb rule, right? Yeah. Okay.
There is no left hand thumb rule.
It's a Fleming's
Oh
right hand
yeah.
rule.
Okay. Sorry, Fleming's left hand rule. Sorry, I meant that.
Yeah. Again, I'm telling you, whatever you studied in 9th and 10th, all the Fleming, the name Fleming also please disappear from your mind. Okay, erase it from your mind. Okay, we're going to use either right hand thumb rule 1 or right hand thumb rule 2. There is no place for left hand. Okay. Okay. Whenever you're getting a wrong answer, your checklist should be this. Am I using the correct hand? Okay. Am I pointing in the correct direction? All three simultaneous, all the two, first vector and second vector, is it essentially in the correct direction? Okay, and then check your final result and it will come in. Most of the times, I'll tell you, most of the times people are using the wrong hand. Okay, so let me just quickly get myself an A4 sheet and a marker so that we can do it together. Till then, please note this down. Okay, I hope everyone has written all the rules here. Okay, let's do this. Okay, so for this, I just need you to okay, write all of this, and then in the bottom is what we are going to discuss. And for that part, I'll unpin this particular presentation. I'm gonna pin my video right here. Okay, so is my video visible to you guys? Can you see me?
Yes, sir.
Okay, you see me in the big screen.
No, sir.
Sir, we have to unpin the presentation ourselves.
Oh, you have to unpin yourself. Please unpin the presentation. Okay, and pin my video.
Okay.
It's very visible.
Please, everyone, do this. You can unpin the presentation and pin my face. Okay, so this right here is a plane. This is right here a plane. Okay, I can keep the plane like this. I can keep the plane like this. Okay, I can keep the plane like this also. Do you understand what is going on? Okay, everyone sees me in the big screen? Unpin the presentation and pin my face, the video camera that I'm presenting. Okay, so essentially what is a plane is essentially the region defined by only two axes. Okay, so if I imagine this is the x-axis and this is the y-axis, then we call this the xy plane. Okay, so if this is x, this is y, z is in the upward direction, then this becomes the xz plane, this becomes the yz plane. Okay, so it's like any area which is defined by just two axes is essentially the definition of a plane. You need at least two axes to define it. So there will be an xy axis, there will be a xz plane, and there will be a yz plane. Okay, so I'm going to talk about the xy plane. I hope things are clear to you.
Can you repeat again from the start? I didn't understand.
Okay, cool. See, first is the directional sense. I told you, the first thing is what we need to do is define an origin. Okay, so let's say this is the origin system. Do you see this on the screen? Okay.
Yes, sir.
The green one is representing the x direction. So that's essentially the direction that is pointing towards, is coming out of the screen for you. Okay. This blue side is going to be the y-axis, and this is going to be the z-axis. Upward direction is going to be the z-axis. Okay. Are you clear with the directional sense?
Yes, sir.
Okay. This is very hard because it's online, but if you pay attention, things will be clear. Okay, this is the direction which is pointing towards the screen is the x-axis. The one to the left of the screen is going to be the y-axis, and the direction going up is z. So if I imagine a plane which has both x and y-axis, what will I call this plane? The xy plane? Yes or no?
Yes, sir.
Okay, a plane that I will make like this is going to be the xz plane.
Yes, sir.
Yes,
And this
sir.
will be the YZ plane.
Yes, sir.
Yes, sir.
Yes, sir.
I hope that made sense. Okay. Now I'm going to talk about XY plane, and I'm going to make two vectors here. Tell me if these diagrams are, like, you can see the diagrams from your end. Okay. Okay. This one. Do you see A vector and B vector?
Yes, sir.
Yes, sir.
Okay. So if this is visible, I'm going to keep it like this. Tell me if this is visible still.
Yes.
Yes, sir.
Yes, sir.
I'm not sure if I should keep it. I think I should keep it like this. Let's use this only. First, the easy case. Let us take the XZ plane to work with. Okay, so it's kept like this. It's parallel to the screen. Okay. Now, how do I use the first right-hand thumb rule? Is very simple. Point all your fingers in the direction of A. Point all your fingers in the direction of A. Now you do it with me. Okay, you do it with me. Right hand, your right hand, not a left hand, guys. I see you left hand, using your left hand. Use right hand, please. Okay. Point all your fingers towards the A vector. Now A vector is going in this direction, so that means I'm going to point all my fingers in the A direction. Notice how I can do this like this also. I can do this like this also. Again, I can do it like this also. All of these are valid. Why? Because in the first step, I have only told you to get all the fingers in the direction of A, and that's it. That's what I have said. Okay. What is the second step though? What is the second step? Curl your fingers towards B. Now, if you keep your hand like this, your fingers are not, it's not going to curl like that. Like if you keep it like this also, is there someone whose fingers go like curl backwards? There's only one way. If you put your fingers like this and you curl like this, where is your finger pointing, guys? It is pointing into the plane. Let me repeat one more time. First step, point all your fingers in the direction of A. Step number 2, curl your fingers towards B. Stick out your thumb and your thumb is pointing into the plane. Please do it with me. Tell me if there is any doubt. In the screen point of view, I think it will be coming out of the screen. It's a perspective. For me, it's coming into the plane, but maybe it's coming out of the plane. Please let me know. Do this cross product. A cross B we are doing. Tell me whether your thumb is coming out of the plane. Point all your fingers towards A and then curl your finger towards B. Is the thumb pointing out of the screen? Please answer.
Yes, sir.
Into the paper, right?
Into the paper.
Sir, into the screen, into the paper.
Yeah. Into the.
Are you using
Pointing
your
towards
right
us.
hand? Guys, are you using your right hand?
Yes, sir.
You're using your right hand, pointing all the fingers in the A direction, is it?
Yes, sir.
For us, yours is sort of mirrored, so we are using your direction.
Like, are you okay?
But with
Just-
the right hand. So
Use your own convention. Just imagine this is the question. Forget me. This is the question. Okay. Use the steps to find out what is the direction of A cross B.
it's going
Point
into
all
the
your
paper.
fingers towards A and point all your fingers towards B. Is it
It's
coming
going
out
into
of
the
the
paper.
Into the
paper.
paper. Into the plane.
Okay, cool. Okay. So what about, okay, what if I ask you to do B cross A in the same one? Do B cross A.
Out
Do
of
B.
the paper.
Out of the paper.
So if you do like this and like this, it's gonna come out of the plane. Are you with me?
Yes, sir.
Yes, sir.
Okay. So I hope you understood this. This is going to be very, very painful to teach in online. Okay. Now let's do the second type of right hand thumb rule. Okay. The second type of right hand thumb rule is again using the right hand. In the right hand, you arrange your fingers like this. Okay. Your pointy finger is pointing away from you. Thumb is pointing up. And you know, if you're looking at from your perspective, your thumb should your middle finger should be pointing towards your left. Okay, your left. So this is how you arrange your hand. Okay, this is how you arrange your hand. Are you with me?
Yes, sir.
Okay. Now if I have A cross B like this, if I have A cross B like this, and I want to find out, let's say B cross A is what I want to find out. Okay, so I don't know how to hold this. Let's hold it like this. Okay, so I have my hand like this. I have my hand like this. Okay, but how will I? I think I have to make it here. Oops. I should keep more A4 sheets with me, I guess. I'm gonna show it like this. Guys, do you see A and B vectors?
Yes, sir.
Yes, sir.
Okay. So the second right hand thumb rule goes something like this. Okay. So you point your index pointy finger in the first direction. Okay. And then you tilt your hand in such a way that B is pointing towards, your middle finger is pointing towards B. Okay. And stick out your thumb. Where is the thumb pointing?
Out of the paper.
Out of the paper. Okay. So I hope everybody is able to do this. If you're unable to do this, please make a similar diagram in your copy and hold it like this and try to do it. Okay. So this is A vector. First finger is pointing towards A. Then rotate your hand in such a way that this is pointing towards B, and then your thumb is pointing outward. Okay. If I keep it like this and then ask you, what is B cross A? What is B cross A? Again, you will do the same thing. This is along B. Okay. Now your hand needs to rotate like this if it has to be in the A plane. And in that case, B cross A will be into the plane. I hope you understood this.
Yes, sir.
During this entire process, you should not make your fingers bend like this. If you make your hand, if you make your middle finger go in the plane of index finger, this is where mistakes are created. Middle finger and your index finger should not be in the same plane. It always should be 90 degrees to each other. The middle finger and the index finger should always make a 90 degree to each other, and the thumb should also be 90 degree to both of them. Keeping this orientation same, do whatever you want, but this orientation should not change, and this hand should not change. Should not be using left hand under any circumstances. Okay, so you go A cross B like this. Okay, A cross B like this coming out of the plane, and B cross A should be like this going into the plane. I hope this makes sense. Okay. I'm not very worried about the ITPL batch or the integrated course, which we are going to meet offline anyway in the coming session. So if you have doubt in this, you can ask me in person. But the online batch students, we have study centers across whole of Bangalore now. Okay, like close to 5 centers. Travel to your nearest center, find a physics teacher and ask him to explain the cross product. You'll do the same. Okay, I'm available both in HSR centers and the Whitefield center. So if you live nearby any of these centers, you can come meet me and we can discuss if you didn't understand the 3D orientation of things happening here. Okay, so this is the right hand thumb rule. Okay, before we go, answer me a few questions. Okay, first question is, if we have, okay, so unpin my face. Okay. Unpin my face and pin the presentation back in. Okay, so if we have two vectors which are essentially parallel to each other, okay, tell me what will be the cross product.
So it'll be 0, right?
0.
Yes, very nice. Because if you see the magnitude of this, you know ki A cross B, A vector cross B vector is essentially given by A B sine of theta and then that r cap. You don't have to reach r cap also. Sine theta, it will always make two parallel vectors cross product equal to 0.
So the direction would be same direction which they are parallel, right?
Yes. Two vectors are called parallel vectors only if their directions are same. If the directions are same, then theta is going to be 0 degree.
No, I'm saying the direction of the product would be the same as the vectors, right?
Direction of the product will be no. The thing is, when you have product itself is 0. Okay. Did you understand, or what? I didn't understand your question. You're asking me the direction of the product. That will be given
the direction of A cross B in this case.
Direction of r cap will be given by right hand thumb rule. It will never be in the plane of A and B.
Okay.
Okay. Second thing is that when you talk about a 0 vector, okay, so A vector cross B vector is going to be 0. 0 vector does not have a definite direction. Okay. When you're doing A cross B and you found out your answer is 0, that means it does not have a magnitude, it does not have a definite direction. Does that answer your question? No? Yes?
Can you please explain again?
Yes, I'm going to explain one more time. Okay. Please write this down, then I'm gonna go to the next page, explain one more time. You don't have to be shy if you need more explanation. You can say, sir, please explain one more time. It's no issues. I'll always explain.
So I had another doubt. I had a doubt.
Yes. Yes.
So where do we use the z-axis? Like we've never, I mean, I personally have never heard of the z-axis until today.
Your voice is very low. Can you repeat?
So where do we use the z-axis? Like,
where do we use z-axis? Well, whenever we're dealing anything in 3 dimensions, like for example, everything around us in 3D, right? If you want to make a car, you have to make it in 3D. You cannot make a 2D car. Okay.
Yes.
So everywhere in engineering that requires 3 dimension, except art. Okay, art requires only 2 dimensions. It doesn't require 3 dimensions. Okay, most of the time. Pen and paper. Okay, so unless you are doing section wise, like for example, you are talking about the cross section of a car. Okay, there you need 2D, but everywhere else you need 3D. Okay.
Sir. So just a small thing. After the class ends, can you just share your number? I want to ask something personally. Well, that is
okay.
Your WhatsApp number will be fine, sir.
Yes, I have WhatsApp number. Do not call me after 9.
I won't call, sir. I'll message.
No, I'll share the number for everyone. No need to worry. After class, I'm gonna share my phone number with everyone. Just make sure don't call
in the group chat.
Can
you share it in the group chat, the number?
Yeah, I will share my number with everyone. No need to worry. You'll get my number.
So actually, I had asked you a doubt after our last class. And you said that you would reply by the next day, but then just in
I
case.
forgot. Yes, that's why I asked you not to DM me. Rather than that, you should ask in the group. That way, even if I'm unavailable, can you let me know what was your doubt?
So I had asked a doubt related to the assignment you had given previously for topic 1. The question 6 and 7 of topic 1. I have a few doubts about that.
Okay. Cool. Stay back after the class 10 more minutes and we'll discuss the previous assignment. If anyone has doubts in the previous assignment, we'll stay back 10 minutes and we'll discuss all the doubts. Okay.
So, and how would we know if the answers we submitted are correct or not? How can we get to know that?
See, the first assignment was the assignment was too easy. So I was thinking once you come back, I'll essentially anybody has any doubts. And also one more thing, the trigonometry based questions at the end, you can just check your answers in the calculator, put the relevant value and check whether what answer you got is correct or not. You can check.
Okay, like I want to know about the other assignment. Would you check and then because I mailed it to you, so would you check and mail it back, or it would be like we'll discuss in the class?
The thing is, when classes start, when your batch is split into I don't know 30-10, online batch people will be submitting their assignments through Class Pro. Okay. Then we will review your assignments, we'll check them and we'll let you know if there are any mistakes in your assignment.
What if it's the IT, like I'm from the IT field batch, so I'll
IT
come
group,
and then
I will be there in your class. I will be checking your copy. Okay.
Oh, okay.
No need to worry. I am going to come to your class and I'm going to check your copy whether you have done it properly or not. So you'll get on-spot review of what you did. Okay.
Okay.
So ITPL people be fully chill because we are meeting in I don't know 17-18 more days. We're gonna meet. When is your school opening? From 25th, is it?
17th of May.
17th of May, right? So yeah, we have what 25 more days and then we are meeting. So no need to worry too much about the assignments. Just keep on doing it in an assignment copy, which I can see when we meet on 17th. I want to see your assignment copies, whether you have done all the assignments or not. The people who are coming in offline, I'm checking anyway daily. But if you're attending online, then please maintain those assignment notebooks because on 17th and 18th when we meet, I want to see your copies. Okay. Let's move forward. This I think someone was asking me, sir, what is the thing with parallel vectors? Parallel vectors essentially means that these vectors have the same direction. The vectors have the same direction. If they have the same direction, the angle between them will be 0. So that means the cross product will have an answer equal to 0. Now, what direction do you assign to 0? Well, anything you assign is going to work because the vector itself is 0. It does not exist. Okay. So that's why we say for 0 vector, the direction is undefined.
Oh, so we don't use, so we can use any direction. Like, we don't
Because
use any
zero,
rule to
zero,
find it.
because zero multiplied by any direction is still zero, right?
Okay.
Okay. So that means it doesn't make any sense to give a particular direction to it. So if you have two parallel vectors, the cross product of that value or those vectors will be zero. I hope you understood that. Similarly, if they are perpendicular to each other, then you just multiply the magnitudes because sine 90 is 1. That is something that you don't need to write, but I hope you understood. Sine 90 is 1. So your A cross B vector, if you're doing for two perpendicular vectors, it just becomes A multiplied by B, because sine 90 is 1. Okay, I don't think I need to mention it, but that is it.
And
Okay?
the direction is find in the same way we just did, right?
Direction is always found out using the right hand thumb rule. There is no left leg, left right leg rule or left hand rule. Just remember, only one of your four limbs are getting used. Okay, the right hand. That's it.
Sir, could
I
you
don't know how
repeat
many
the
times I have to emphasize this. I have exhaustively discussed this in class, but people still end up using their left hand. Please do not do that. Yes.
Sir, could you repeat the relevance of the R cap?
The relevance of R cap. R cap is essentially the direction in which your answer is. Like for example, force is acting, upwards, and let's say R is in your right. So what is the direction of torque? It is neither, it's not going to be up or right, it's going to be towards you. Okay, no, sorry, it's going to be backwards. Okay, and all of that will be discussed when we are talking about actual torques, and we'll be doing revising cross product one more time. But one thing that you should take away from this are the two right hand thumb rules. For any two simple given vectors, A vector and B vector, you should know how to find out A cross B cut direction. Okay, similarly, both the ways, using this and using the curl thingy. Okay, whichever one you use, please stick to it forever. Do not use both. Okay, so if you're using the curl method, I like to use the curl method. You might use the pointy finger 90 degrees one, but it's hard for me to rotate like that. Okay, it is more difficult than this for me personally. Okay, with that, I'd like to conclude today's class. Next class, we'll start with analytical cross product, how to do it, and a small shortcut to it. And also we'll study a little bit of constraint motion. Okay, so the next topic that we are going to discuss is known as constraint motion, which is essentially, it falls under both maths and physics. Its uses in physics is more. Okay, till then, I'll see you next class. Till then,
So we're not doing algebraic cross product.
Yeah, that's what I said. We'll do in next class. We'll do algebraic cross
So you said the class is till 12:30, so we have 20 more minutes.
No. I already announced in the group that the class is lasting up to 12 o'clock. So I have to maintain that. But next time on, I'll try to, I said I'll try to increase the class to 12:15 or 12:30, because I want to give a 15-minute break in between for your minds to get settled before the next session. Okay. So again, whatever reminder I set, I will adjust that reminder accordingly. Okay. So now I'll just stay back 15 more minutes so that I can take people's doubts. Okay. If you don't have any doubts, you can leave. I'm going to discuss the previous assignment quickly. Okay. If there are any fancy questions that need answered.
So the recording and the notes, so will you be sending it in the WhatsApp group for the
Yes, today's class recording is done, but it's gonna take some time to process. So I think 1.5 hour, 2 hours it takes to process the video, the 3-hour video that we did. Then I'm gonna send the link to that video in the group. I'm gonna send today's class notes, and I'm also gonna send the assignment relevant to today's class. Okay, and all of these will be available before 5 p.m. today. Okay, no need to worry.
Okay, so thank you.
Okay. So I'm going to quickly pull up the last week's assignment. Till then, please give me some time. Okay. If you don't have a doubt, then you can leave.
Thank you, sir.
Thank you so much for
Thank
being
you,
here,
sir.
guys. It was great having you. Yes. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you. Thank you. Actually, the designated class is up to 12:30 only. Yeah, I messed it up today. Next class on will make it sure. Yes, students, is anyone left? Yes, I think 2 people are left. Meghna is here and Ramaharshini is here, I think. No, 4 people are left.
Sir,
Oh, me included. Yes.
sir, I'm actually traveling.
Uh-huh.
So I'll reach school. I'll reach Bangalore on 19th of May. So I'll be attending NPS ITPL from 28th. Is it fine?
It is fine. There is no option. Where are you traveling?
Yeah, I'm in Bihar.
You're traveling where?
I'm traveling in Bihar.
Oh, I see. So it's okay. It's okay if it's you're already out, so that might have already been planned. Make sure to keep attending the online sessions in between.
Yeah, yeah.
And
And
after coming
and
back,
the-
consult me and talk about whatever you missed out on.
okay. And the assignments. Can we write all the subject assignments in the same book?
All the subjects.
Yeah.
No, you have to carry 3 notebooks. It doesn't have to be very. What you could do, I've seen some students do this. They just take a bunch of sheets with them, okay? And once they're done with the assignment, they will staple it and they will keep it in the physics file. That also works.
Okay,
If
fine.
you're worried about carrying too much stuff around with you, just carry a bunch of papers, do them, staple those papers, and put it in a small file that is given as physics.
Okay, okay. Thank you.
Thank you. Yeah, which question in the assignment would you like me to discuss?
Are you asking me?
Yeah, whoever is left. There's one more person left.
No, I don't have any doubt in that. It was pretty easy.
Oh, there was one guy who asked me and then left. What the?
Yeah.
Yeah. Anyway, thank you for being here. I'm gonna end this call.
Yeah, sure.
Take care, guys.